Week 2 BU 631 readings, Project Management for Business Professionals. In this unit, we will expand our understanding of project management best practices to utilize standard project methodologies as well as specific activities and tools more thoroughly. We will evaluate and apply the stages of a project to better plan and execute against organizational strategy. We will evaluate how project managers effectively control time and cost factors in projects. Finally, we will begin to create a comprehensive project plan. In this topic area, we will examine the waterfall approach to project management. This approach is the older of the two standard methodologies and is commonly used for various project types. We will examine when this approach is most appropriate and how it can be employed to complete projects successfully. Chapter Preview and Objectives. Before you can begin understanding the practice of managing projects, you need to have a clear understanding of the processes and key tools, methods, that define project management. This chapter describes the project management framework, consisting of process groups, knowledge areas, and component processes. You will understand the project management framework when you can. Define the 5 process groups and understand how they interact over time. Define the 10 knowledge areas. Define the component processes that exist within each process group. Know the methods used in each component process and the deliverables produced. Define the project performance domains and map them to the 10 knowledge areas. Understand the importance of the Project Management Institute and other professional societies. A framework for project management. As mentioned earlier in this book, in the late 1950s and early 1960s, the term project management emerged as projects began to grow rapidly in scope, size, duration, and resources. In 1969, the Project Management Institute, PMI, was founded for the following reasons: to create a forum for project managers to discuss emerging concepts and practices, to officially recognize project management as a profession in and of itself, to bring together people from all branches of project management to share and learn from each other. In the early 1970s, PMI conducted seminars and symposiums in the United States and overseas, created its first local chapter, and had membership of 2,000. Worldwide. By the end of the 20th century, membership soared from 2,000 to over 50,000, and special interest groups, SGs, were created. In 1994, the first edition of a guide to the Project Management Body of Knowledge, PMBOK, was published. PMI created several publications to assist in the dissemination of project management knowledge during the 1970s through 1990s, such as journals, newsletters, and magazines. As of July 2021, PMI had more than 660,000 members in more than 219 countries, and it had many SGs, such as information systems and manufacturing. PMI offers and controls the leading certification credential today, Project Management Professional, PMP. We will talk more about this and how to get certified later in the text. Certifications can be an important part of ensuring quality in a profession. In 1999, PMI became the first organization in the world to have its certification program receive the International Organization for Standardization, ISO, 9001 recognition. As of July 2021, PMI had certified more than 1.2 million PMPs. The growth in PMI membership and participation is analogous to the growth in project management awareness and importance, and demonstrates the importance that PMI plays in the future directions of this profession. Although PMI is the largest professional project management society, it is not the only one. Several others are growing as well, including the International Project Management Association, IPMA, and APMGK, which is a proponent of the projects in controlled environments, Prince2 methodology. In addition, because of the increased importance of the project management profession globally, The ISO Standards Committee in 2012 released standard ISO 21500, titled Guidance on Project Management. This standard, which closely resembles the PMBOK, is the first in a family of related project management standards scheduled to be released. The PMBOK is a starting point, not an endpoint. Organizations rarely adopt the entire PMBOK as is. They use it as a starting point and then develop their own framework, filled with processes, phases, and methods. We have done the same thing with this book. We started with the PMBOK and have added our own flavor to it to give you added definition and understanding. This chapter introduces the concepts of the framework, and subsequent chapters will explain them in detail. The basic structure and terminology presented in this text is from a guide to the PMBOK 6th and 7th editions. The methods discussed in subsequent chapters are based on material from the PMBOK, other authors, and this text's author's own combined 70 years of information technology project management experience. Why is the structure of our text based on the PMBOK? As stated in earlier chapters, project management has become a strategic necessity in today's organization. Like many other professions, such as computer science, accounting, or engineering, project management needed to create a shared knowledge base from which research and maturity of practices could be established. A common language is needed to allow researchers and practitioners to communicate across departments, organizations, industries, and countries. The PMBOK establishes this common language. More than 3 million copies of it are in circulation, and it has been translated into 8 different languages. The framework used in this text, see Figure 3.1, is structured around 5 process groups, which are made up of component processes consisting of tools, techniques, and outcomes organized within 10 knowledge areas. As indicated by the empty boxes in Figure 3, 1. Not all knowledge areas apply to every process group. For example, integration management and stakeholder management apply to the initiating process group, and all the other knowledge areas have empty boxes. We will discuss and define each of the process groups and knowledge areas in the following sections. In the 7th, most recent, edition of the Guide to the PMBOK, PMI made some major changes to the structure of the material for the following reasons: to better reflect newer development approaches, namely Agile, flexibility to address more project types across a broad spectrum of business domains, and to better emphasize the importance of creating value in all its forms to meet organizational objectives. The standard for project management defines 12 principles instead of process groups. The 12 principles, along with the chapter of this text they are covered in, are Stewardship 5, 6, Team 5, 10, 12, Stakeholders 7, Value 1, Systems Thinking 2, Leadership 10, Tailoring 3, Quality 7, 12, Complexity 1, Risk 8, Adaptability 10, and Resiliency 10, and Change 11. PMI has created a great reference tool with new research and methods for experienced project managers in the 7th edition of the PMBOK. Unfortunately, the resource is now not very user-friendly for new learners. The previous version of the guide gave us a process structure that we as instructors could use to help new learners understand what a project manager actually does throughout a generic project. We could then discuss exceptions to the standard to incorporate newer, Agile process approaches. This is why, in our 4th edition of this text, we have continued to use the process-based approach used in earlier versions of the PMBOK to aid new learners, which has always been the focus of our text. The process group's 5 basic process groups are used to conduct a successful project. Initiating, this group deals with authorizing the beginning or end of a project or phase. Planning. This group deals with ensuring that the objectives of a project are achieved in the most appropriate way. Execution. This group deals with coordinating all resources, people, and material during the implementation of the project plan. Controlling. This group deals with monitoring project variances from what was planned to actual progress. Closing. This group deals with formal acceptance of the project or a phase and updating the project information base with lessons learned. These process groups consist of several individual component processes that turn inputs into outputs during each phase of the project. Chapters 4 through 13 of this text describe each of these processes and the methods, tools, and techniques used in each. Throughout the text, the process groups are covered in a sequential, linear format, but in fact the process groups overlap with varying intensity during the execution of a project. For example, in Figure 3.2, the vertical axis displays the varying amount of work or activity for each process group that occurs on many projects, and the horizontal axis depicts how the process groups overlap over time. Soon after the project initiation process group begins, planning processes can begin, and controlling processes should begin. For example, the project charter is one of the main documents created during project initiation. Because this document contains signatures of key stakeholders or project sponsors, the project charter needs to be put under configuration control, a process for controlling and tracking changes as soon as it is done, which is a method used within the controlling processes. Don't worry about what these documents or methods are right now. They will be thoroughly explained later in the text. During the execution process, the initiating, planning, and controlling processes can also be in operation. The process groups are linked to each other by the outcomes they produce. The outcome of one group is often the input into another, as indicated in Figure 3.3. For example, the project charter is an output from initiation and is one of the key inputs into the planning process. Figure 3. 3 process groups interacting in a phase. Figure 3 demonstrates how process groups exist within each phase of an iterative project. Iterative projects are defined in Chapter 2. The initiating process group is the process that begins the project as well as each phase. Each phase consists of all 5 process groups interacting over time. Each phase as well as the entire project ends with the closing process. As each phase ends, the closing process reviews what was accomplished in the previous phase and what needs to be done or redone in the next phase. Process groups supply a roadmap to follow, and the knowledge areas describe the methods, for example, car, plane, bus, of how to get to our destination, which is project success. The next section presents an overview of the 10 knowledge areas. The knowledge areas as defined earlier, a knowledge area describes project management knowledge in terms of its component processes. The 10 knowledge areas are integration management, scope management, schedule management, cost management, quality management, resource management, communications management, risk management, procurement management, stakeholder management. The knowledge areas represent the body of knowledge that a project manager must have in order to consistently deliver successful projects that meet a customer's expectations in terms of scope, time, cost, and quality of the project deliverables as depicted in Figure 3-4. Figure 3.4 depicts the process of project management as an integrated machine. Project requirements/specifications are funneled into the machine to start it running. Project requirements are the raw materials feeding the machine, and the product deliverables are the finished goods. The core knowledge areas of scope, schedule, cost, and quality are represented by the large gears that must be there to make it all work. The facilitating knowledge areas, stakeholder, risk, procurement, and resources are attached to the flywheel to help the gears of the key processes along. And connecting the core knowledge area gears to the facilitating knowledge area flywheel is the integration knowledge and communication area gears. The output of the machine, product deliverables, is controlled by the customer. They alone are the ones who determine the success or failure of your project. Success is measured by the customer's perception of the quality of the delivered product. The individual knowledge areas are defined in Table 3.1. Each of these definitions includes a list of tasks, component processes, that are executed to produce the outcomes dictated by the knowledge area. The individual component processes are defined later in the chapter. The component processes, as stated earlier and shown in Figure 3, 1. The project management framework presented in this text, which is based on work done by PMI, consists of 10 knowledge areas presented on the vertical axis and 5 process groups organized across the top on the horizontal axis. At the intersection of the two, the component processes are presented, the project management processes that are common to many projects, and the major deliverables produced by those processes. The following sections introduce the component processes of each process group, as well as the major deliverables produced. Later chapters provide examples of the major deliverables and explain how to create them. Initiating component processes and major deliverables before the project begins, a critical activity occurs, selecting the right project to work on. Chapter 4 helps the reader determine which project to work on and figure out how best to select the right mix or portfolio of projects for your organization. Even if a project is run perfectly, but it turns out the organization is headed in a different direction, valuable resources and time can be wasted. The projects chosen must be in step with the organization's strategic plan. Chapter 4 describes some key methods you can use to help with strategic planning. The initiating group applies to the integration management knowledge area and the stakeholder management knowledge area of the framework. As illustrated in Figure 3.5, it consists of project initiation. Project initiation, the process of formally authorizing a new project or determining that an existing project should proceed into its next phase. Recall from Chapter 2 that the initiation phase is where these stage-gate decisions, to proceed with the project or not, are made. As a result of the project initiation process, 2 major deliverables are produced. Project Charter. This document formally authorizes a project. It should include, or may reference another document, the business need that the project must address, a description of the product to be created, critical success factors, and identification of the project manager. The project manager should be identified and assigned as early in the project as feasible. In many cases, the project selection process happens first, and then, after the project is selected for execution, an appropriate manager is chosen to lead the effort. Project assumptions. These are factors that for planning purposes are considered to be true, real, or certain. Project constraints. These are factors that limit the project management team's options. Stakeholder register. This document summarizes all the stakeholders, people or organizations, that are affected by some part of the project. You can think of the project charter as the course syllabus you are handed at the beginning of each semester from each course. The syllabus, hopefully, contains a list of objectives, a high-level schedule, work expectations, policies, and information about the project leader, professor. If all this information is clearly laid out and followed, the chances the course will run smoothly are enhanced. If there is a problem during the semester and you need to hand in a homework assignment late, you only need to check the syllabus to see if it can be handed in at all and what type of grade penalty will be assessed. With a well-defined syllabus, questions can be answered quickly, and each student is treated fairly and consistently. Projects also rely on a good charter to help in answering questions and knowing what the key deliverables are and when they are needed. Planning component processes and major deliverables before jumping into the planning component processes. Think about a couple of quotes. First, consider the following from Lewis Carroll's Alice in Wonderland. The king says to Alice, "Begin at the beginning and then go till you come to the end, then stop." This is, unfortunately, how many companies do their planning. They don't. They start a project with no idea of what is required to complete it, so they never end. Now think about another famous quote, "Those who fail to plan to fail." Doing a good job of planning can't be stressed enough. The largest number of tools for any of the 5 process groups exists in the planning group. T. Capers-Jones, 1998, states. Figure 3, 5 initiating component processes and major deliverables. The seeds of major software disasters are usually sown in the first 3 months of commencing the software project. Once a project blindly lurches forward toward an impossible delivery date, the rest of the disaster will occur almost inevitably. Page 120. The errors we make in the initiation and planning processes are much more significant than at any other time. The planning group consists of component processes and deliverables that are applicable to every knowledge area of the framework, as shown in Figure 3.6. In integration management, the process is as follows. Develop project management plan. This process uses the outputs from the other planning processes to create a consistent and coherent document that can be used to guide both project execution and project control. The primary deliverable of project plan development is the project plan, project management plan. This formal approved document is used to manage project execution. The project plan can be expected to change over time when new information about the project becomes available. A good deal of this text is devoted to building pieces of the project plan. The planning processes of scope management are collect requirements. This is the process of discovering, defining, and documenting stakeholders' needs to meet stated project objectives. Define scope. This is the process of subdividing the major project deliverables into smaller, more manageable components. Plan scope management. This is the process of creating a scope management plan. Create work breakdown structure, WBS. The WBS is a deliverables-oriented grouping of project components that organizes and defines the total scope of a project. As with the scope statement, the WBS is often used to develop or confirm a common understanding of project scope among the stakeholders. Let's again use the course syllabus example from earlier in this chapter. Many syllabi include a complete list of assignments, number of exams, and so on that a student is asked to complete during the semester. The WBS defines each outcome or deliverable that is required to build the product. As a result of the scope planning processes, 6 major deliverables are produced. Scope management plan, a scope management plan that documents how the project scope will be defined, validated, and controlled. Figure 3, 6 planning component processes and major deliverables requirements management plan, a component of the project management plan that describes how requirements will be analyzed, documented, and managed. Requirements documentation, a description of how individual requirements meet the business need for a project. Requirements traceability matrix, a grid that links product requirements from their origin to the deliverables that satisfy them. Scope statement provides a documented basis for making future project decisions and for confirming or developing a common understanding of project scope among the stakeholders. Brewer, Jeffrey L., and Kevin C. Dittman. Methods of IT Project Management, 4th edition, Purdue University Press, 2022. ProQuest eBook Central, http://ebookcentral.peerocase.com/lib/herzing-ebooks/detail.action?mark.id=6903522. Created from Herzing eBooks on July 13, 2025, 1:09 and 25 seconds. Copyright 2022. Purdue University Press. All rights reserved. Ebook pages 22 to 97 printed page 64 of 82 scope baseline, the approved version of the scope statement, work breakdown structure, WBS, and its associated WBS dictionary, which can be changed only through formal change control procedures and is used for a basis of comparison. In addition, any previously created documents are updated to reflect any new information. The planning processes of time management are plan schedule management is the process of establishing the policies, procedures, and documentation for planning, developing, managing, executing, and controlling the project schedule. Define activities. This process involves identifying and documenting specific activities that must be performed to produce deliverables and subdeliverables identified in the WBS. Sequence activities. This process involves identifying and documenting interactive logical relationships, that is, identifying the sequence in which the activities must be performed in order to produce a realistic and achievable project schedule. Estimate activity resources. This process is used to determine which resources are being utilized and how much of each resource is available. Estimate activity durations. This process involves estimating the number of work units, for example, hours, days, weeks, required to complete each activity. This involves taking information on project scope and resources and then developing durations for input to schedules. Develop schedule. This is the process of analyzing activity sequences, activity durations, and resource requirements to create the project schedule. As a result of these processes, 6 major deliverables are produced. Schedule management plan, a component of the project management plan that establishes the criteria and the activities for developing, monitoring, and controlling the project schedule. Activity list and attributes. This list includes all the activities that will be performed on the project as well as characteristics of each activity. In addition, a milestone list may be created which lists all the project milestones and whether they are mandatory or optional. Project network diagrams. These are schematic displays of the project activities and the logical relationships, dependencies, among them. The most common type of project network diagram is called a PERT, Program Evaluation and Review Technique, chart. Activity resource requirements. These are the hours available from each resource for each task. In addition, a resource breakdown structure may be created which illustrates resources by category and type. Activity duration estimates. These are quantitative assessments of the likely number of work periods, for example, hours, days, weeks, that will be required to complete an activity. Project schedule/calendar. This approved, baselined. Deliverable includes at a minimum the planned start and expected finish dates for each activity. The project schedule can be presented in tabular form or graphically using a project network diagram or using special types of bar charts called Gantt charts and milestone charts. The schedule should also have a management plan that defines how changes to the schedule will be managed as well as calendars that defines working and non-working times. In addition, any previously created documents are updated to reflect any new information. The planning processes of cost management are plan cost management is the process that establishing the policies, procedures, and documentation for planning, managing, expending, and controlling project costs. Estimate costs. This process involves developing an approximation, estimate, of the costs of the resources needed to complete project activities. Determine budget. This process involves allocating the overall cost estimates to individual activities or work packages to establish a cost baseline for measuring project performance. As a result of these processes, 4 major deliverables are produced. Cost management plan, a component of the project management plan that describes how costs will be planned, structured, and controlled. Activity cost estimates. These are quantitative assessments of the likely costs of the resources required to complete project activities. The cost estimates get more accurate over time. Later chapters discuss the concept of progressive elaboration as it applies to budgets. In addition, basis of estimates, BEs, may be produced which is supporting documentation detailing what information and process was used to prepare the estimates. Brewer, Jeffrey L., and Kevin C. Dittman. Methods of IT Project Management, 4th edition, Purdue University Press, 2022. ProQuest eBook Central, http://ebookcentral.pirocast.com/lib/herzing-ebooks/detail.action?mark.id=6903522. Created from Herzing eBooks on July 13, 2025. 109 and 25 seconds. Copyright 2022. Purdue University Press. All rights reserved. Ebook pages 22 to 97, printed page 65 of 82A. B, C, D, E, cost baseline. This is a time-phased budget that will be used to measure and monitor cost performance on a project. Funding requirements. Both periodic and total funding requirements are needed to deliver all documented requirements on projects derived from cost estimates. In addition, any previously created documents are updated to reflect any new information. Quality management has only one planning process: plan quality management. This process involves identifying which quality standards are relevant to a project and determining how to satisfy them. As a result of quality planning, for major deliverables are produced. Quality management plan. This formal or informal document describes how the project management team will implement its quality policy. Quality metrics in very specific terms, what something is and how it is measured by the quality control process. Checklists, specific lists, are used to verify that a set of required steps has been performed. Process improvement plan, a component of the project management plan that details steps for analyzing processes to identify activities that enhance their value. In addition, any previously created documents are updated to reflect any new information. The planning processes of human resources management are plan resource management. This process involves identifying, documenting, and assigning project roles, responsibilities, and reporting relationships. As a result of this process, one major deliverable is produced consisting of 3 sub-deliverables. Resource management plan, a component of the project management plan that describes how physical resources, equipment, materials, facilities, and infrastructure will be obtained and used, the roles and responsibilities, reporting relationships, and staff management will be addressed and structured. This plan consists of the following components: role and responsibility assignments. These assignments include project roles, who does what, responsibilities, who decides what, and who has what authority that must be assigned to the appropriate project stakeholders. Staffing management plan. This formal or informal document describes when and how human resources will be brought onto and taken off the project team. It also describes their available time to work on a project, any training needs, any pertinent human resources policies or regulations, and any safety guidelines. Organizational chart. This is a graphical display of project reporting relationships that communicates who works for or reports to whom among the project team members and stakeholders. In addition, any previously created documents are updated to reflect any new information. Communications management has only one planning process: plan communication management. This process involves determining the information and communications needs of the stakeholders, who needs what information, when they will need it, how it will be given to them, and by whom. As a result of communications planning, one deliverable is produced: Communications Management Plan. This formal or informal document provides what methods will be used to gather and store the various types of information to whom information will flow, and what methods will be used to distribute the various types of information, a description of the information to be distributed, methods for accessing information between scheduled communications, a method for updating and refining the communications management plan as the project progresses and develops. In addition, any previously created documents are updated to reflect any new information. The planning processes of risk management are plan risk management. This process involves deciding how to approach and plan the risk management activities of the project. Identify risks. This process involves determining which risks might affect the project and documenting their characteristics. Perform qualitative risk analysis. This process involves performing a qualitative analysis of risks and conditions to prioritize their effects on project objectives. Brewer, Jeffrey L., and Kevin C. Dittman. Methods of IT Project Management, 4th edition, Purdue University Press, 2022. ProQuest eBook Central, http://ebookcentral.herochaos.com/lib/herzing-ebooks/detail.action?doc ID = 6903522. Created from Herzing eBooks on July 13, 2025, 1:09 and 25 seconds. Copyright 2022. Purdue University Press. All rights reserved. Ebook pages 22 to 97, printed page 66 of 82A. B. Perform quantitative risk analysis. This process involves measuring the probability and consequences of risks and estimating their implications for project objectives. Plan risk responses. This process involves developing procedures and techniques to enhance opportunities and reduce threats to the project's objectives. As a result of these processes, 3 major deliverables are produced. Risk Management Plan. This document describes how risk identification, qualitative and quantitative analysis, response planning, monitoring, and control will be structured and performed during the project lifecycle. List of analyzed risks. Register. This list, or multiple lists, include prioritized qualitative and quantified risks for additional analysis and management risk response plan. This document describes what actions will be performed for each risk identified. In addition, any previously created documents are updated to reflect any new information. The planning process of procurement management is Plan procurement management. This process involves determining what to procure, when to procure, and a list of potential sellers. As a result of this process, 3 major deliverables are produced. Procurement Management Plan. This document describes how the remaining procurement processes, from solicitation planning through contract closeout, will be managed. Statements of work. This document describes the procurement item in sufficient detail to allow prospective sellers to determine if they are capable of providing the item. Procurement documents. These documents, for example, requests for proposal, RFPs, are used to solicit proposals from prospective sellers. In addition, any previously created documents are updated to reflect any new information. The planning process of stakeholder management is Plan stakeholder management. The process of developing appropriate management strategies to effectively engage stakeholders throughout the project lifecycle, based on the analysis of their needs, interests, and potential impact on project success. As a result of this process, 1 major deliverable is produced, Stakeholder Management Plan, a component of the project management plan that defines the processes, procedures, tools, and techniques to effectively engage stakeholders in project decisions and execution based on the analysis of their needs, interests, and potential impact. Execution component processes and major deliverables. The execution group consists of component processes and deliverables that apply to 6 of the knowledge areas of the framework, as shown in Figure 3.7. Recall from Chapter 2 that this is where the product actually gets built. The product-specific lifecycle begins to generate product-specific deliverables. In integration management, the process is as follows. Brewer, Jeffrey L., and Kevin C. Dittman. Methods of IT Project Management, 4th edition, Purdue University Press, 2022. ProQuest eBook Central, http://ebookcentral.herochaos.com/lib/herzing-ebooks/detail.action?doc ID = 6903522. Created from Herzing eBooks on July 13, 2025, 1:09 and 25 seconds. Copyright 2022. Purdue University Press. All rights reserved. Ebook pages 22 to 97, printed page 68 of 82. Direct and manage project work. This process is used to carry out the project plan by performing the activities included therein. As a result of project plan execution, 3 major deliverables are produced. Deliverables. These are the outcomes of the activities performed to accommodate the project. Implemented changes. These are changes to project scope, project costs, budgets, or the project schedule. Work performance information. This is information collected on the current status of the project activities. In addition, any previously created documents are updated to reflect any new information. There is only one execution process in quality management: manage quality. This process involves evaluating overall project performance on a regular basis to provide confidence that the project will satisfy the relevant quality standards. As a result of the quality assurance process, one primary deliverable is produced: quality improvement. This includes taking action to increase the effectiveness and efficiency of the project to provide added benefits to the project stakeholders. There are 3 execution processes in resource management. Acquire resources. This process involves finding and acquiring the human resources and physical resources needed to execute the project. Develop team. This process involves developing individual and group competencies to enhance project performance. Manage team. This process involves tracking each team member's performance during the project and coordinating changes. As a result of the team development process, 3 deliverables are produced. Staff assignments. Appropriate people are assigned to each task on the WBS. Resource availability. Each person may have different time periods available to work on a project. Many individuals work on more than one project at a time, and they need to split their time. Performance assessment. Project managers need to continually evaluate the effectiveness of each team member and the team as a whole. There is one execution process in communications management: manage communications. The process of creating, collecting, distributing, storing, and retrieving project information in accordance with the Communications Management Plan. As a result of this process, one major deliverable is produced: project communications, information distributed to the stakeholders using the appropriate media and format. In addition, any previously created documents are updated to reflect any new information. The execution process of procurement management is conduct procurements. This process involves obtaining quotations, bids, offers, or proposals as appropriate and choosing solutions from among potential sellers. As a result of this process, 4 primary deliverables are produced: selected sellers. This is a list of qualified sellers based on predetermined selection criteria. This is generally more than one after the initial review of the proposals. Agreements, a document such as a contract that defines the intentions of the project. Resource calendars, a calendar that identifies the working days and shifts in which the resources are available. Change request, a formal proposal to modify the procurement agreement. In addition, any previously created documents are updated to reflect any new information. The execution process of stakeholder management is: manage stakeholder engagement. This is the process of communicating and working with stakeholders to meet their needs/expectations and address issues as they occur throughout the life cycle. As a result of this process, 2 major deliverables are produced: issue log, a document used to document and monitor elements under discussion or in dispute between project stakeholders. Change request, a formal proposal to modify an approved document. In addition, any previously created documents are updated to reflect any new information. The process group execution, its inputs and outputs, as well as the tools and techniques used are explained in detail in Chapter 10. Controlling component processes and major deliverables. The monitoring and control group consists of component processes and deliverables that are applicable to all but one of the knowledge areas of the framework, as depicted in Figure 3.8. In integration management, the processes are as follows: Brewer, Jeffrey L., and Kevin C. Dittman. Methods of IT Project Management, 4th edition, Purdue University Press, 2022. ProQuest eBook Central, http://ebookcentral.pirocast.com/lib/herzing-ebooks/detail.action?doc ID =$6903522. Created from Herzing eBooks on July 13, 2025, 1:09 and 25 seconds. Copyright 2022. Purdue University Press. All rights reserved. Ebook pages 22 to 97, printed page 71 of 82 monitor and control project work. This process involves monitoring project progress, scope, time, cost, and quality throughout the entire life cycle. Perform integrated change control. This process involves coordinating changes across the entire project. As a result of this process, 3 primary deliverables are produced. Change request, a formal proposal to modify the project management plan. Work performance reports, project documents containing information to assist in generating decisions, actions, or awareness. Examples of these include corrective action. Is anything done to bring expected future project performance in line with the project plan? Forecasts, estimates of conditions in the project's future based on information available at the time the forecast is made. Lessons learned is documentation that details the causes of variances, the reasoning behind the corrective action chosen, and other types of lessons learned. Change log, a comprehensive list of changes made during the project, which include the date the change was made, and the impact in terms of time, cost, and risk. In addition, any previously created documents are updated to reflect any changes. The controlling processes of scope management are validate scope. This process involves formalizing acceptance of the project scope. Control scope. This process involves controlling changes to the project scope. As a result of the scope validation and scope change control processes, 3 primary deliverables are produced. Formal acceptance. This is documentation that the client or sponsor has accepted the product of the project phase or major deliverables must be prepared and distributed. Change requests. This is any modification to the agreed-upon project scope as defined by the approved WBS. Work performance information. Project performance information as it pertains to scope. How much has been completed, how many changes, etc. In addition, any previously created documents are updated to reflect any changes. The schedule management knowledge area consists of one controlling process, control schedule. This process involves controlling changes to the project schedule. As a result of the schedule control process, 3 major deliverables are produced. Schedule forecasts, estimates of conditions in the project's future based on information available at the time the forecast is made. Change request, a formal proposal to modify the project schedule. Work performance information, project performance information as it pertains to the schedule. Using earned value terms, the schedule variance and schedule performance index values for selected WBS activities. In addition, any previously created documents are updated to reflect any changes. The cost management knowledge area consists of one controlling process, control cost. This process involves controlling changes to the project budget. As a result of the cost control process, 3 major deliverables are produced. Cost forecasts, estimates of conditions in the project's future based on information available at the time the forecast is made. Change request, a formal proposal to modify the project's budget. Work performance information, project performance information as it pertains to the cost/budget. Using earned value terms, the cost variance and cost performance index values for selected WBS activities. In addition, any previously created documents are updated to reflect any changes. Quality management has only one controlling process, control quality. This process involves monitoring specific project results to determine whether they comply with relevant quality standards and identifying ways to eliminate causes of unsatisfactory performance. As a result of quality control, 5 major deliverables are produced. Quality control measurements. These are collected results of quality control activities for evaluation against the quality standards. Validated changes. Items are reinspected and approved or disapproved. Change request. A formal proposal to modify a project activity in order to improve the quality of the project. Verified deliverables. In the end, all deliverables should meet stated requirements of the stakeholders. Work performance information. Project performance information as it pertains to the cost/budget. Using earned value terms, the cost variance and cost performance index values for selected WBS activities. In addition, any previously created documents are updated to reflect any changes. Resource management has only one controlling process: control resources. This process involves controlling changes to the resource plan. As a result of resource control, 2 major deliverables are produced: change request, a formal proposal to modify a resource. Work performance information, resource performance information as it pertains to human resource performance. The controlling process of communication management is monitor communications. This is the process of monitoring and controlling communications throughout the life cycle to ensure the information needs of the project stakeholders are met. As a result of the communications management monitoring and control process, 2 major deliverables are produced. Work performance information, project performance information as it pertains to status reporting, progress measurement, and forecasting. Change request, a formal proposal to modify the project's schedule, scope, or budget costs. In addition, any previously created documents are updated to reflect any changes. The controlling process of risk management is monitor risks. This is the process of implementing risk response plans, tracking identified risks, monitoring residual risks, identifying new risks, and evaluating risk process effectiveness throughout the project. As a result of the risk management monitoring and control process, 2 major deliverables are produced: work performance information, project performance information as it pertains to risk process effectiveness. Change request, a formal proposal to modify the project's schedule, scope, or budget costs because of a risk event. In addition, any previously created documents are updated to reflect any changes. The controlling process of procurement management is control procurements. This is the process of managing procurement relationships, monitoring contract performance, making changes to contracts as appropriate, and closing out contracts. As a result of the procurement management monitoring and control process, 2 major deliverables are produced: work performance information, project performance information as it pertains to contract performance of both the buyer and the seller. Change request, a formal proposal to modify or correct provisions of the contract between the buyer and the seller. In addition, any previously created documents are updated to reflect any changes. The controlling process of stakeholder management is monitor stakeholder engagement. This is the process of monitoring overall project stakeholder relationships and adjusting strategies and plans for engaging stakeholders. As a result of the stakeholder management monitoring and control process, 2 major deliverables are produced: work performance information, project performance information as it pertains to effectiveness of stakeholder engagement. Change request, a formal proposal to modify a stakeholder management document. In addition, any previously created documents are updated to reflect any changes. The control group, its inputs and outputs, and the tools and techniques used are explained in detail in chapters 11 and 12. Closing component processes and major deliverables. The closing process group consists of component processes and deliverables that are applicable to one of the knowledge areas of the framework, as shown in Figure 3.9. In integration, the process is as follows: close project or phase. At the official end of one phase of the project or the entire project, collect any remaining project performance metrics. As a result of the closing project process, 5 deliverables are produced: final project or service. This is the end product as a result of completing the project, which includes the confirmation that the project has met all customer requirements deemed necessary for the product or service of the project. Project archives. This is a complete set of indexed project records. Formal acceptance. Stakeholders formally acknowledge signatures, the acceptance of the product. Lessons learned. This is documentation that details the causes of variances, the reasoning behind the corrective action chosen, and other types of lessons learned. Team member assessments. These are evaluations of each team member's work performance on the project. The process group closing, its inputs and outputs, and the tools and techniques used are explained in detail in Chapter 13. Brewer, Jeffrey L., and Kevin C. Dittman. Methods of IT Project Management, 4th edition, Purdue University Press, 2022. ProQuest eBook Central, http://ebookscentral.purokchaos.com/lib/herzing-ebooks/detail.action?mark.id=6903522. Created from Herzing eBooks on July 13, 2025, 1:09 and 25 seconds. Copyright 2022. Purdue University Press. All rights reserved. Ebook pages 22 to 97, printed page 74 of 82 Framework Summary. This chapter presents an introduction to the project management framework based on the PMI's PMBOK. The text uses the framework as a visual guide and reminder about where you have been and where you are going in terms of learning the project management process, as well as the tools and techniques that successful project managers use to bring projects in on time, under budget, and meeting stakeholders' expectations for value delivery. The following chapters discuss in detail the common project management processes, the inputs to those processes, the tools and techniques project managers use, and the outputs, deliverables, produced as a result of the processes. Figures 3, 10, and 3 to 11 provide a summary of the framework introduced in this chapter and the major deliverables described here. Chapter review. In the late 1950s and early 1960s, the term project management emerged as projects began to grow rapidly in scope, size, duration, and resources. In 1969, the Project Management Institute, PMI, was founded for the following reasons: to create a forum for project managers to discuss emerging concepts and practices, to officially recognize project management as a profession in and of itself, to bring together people from all branches of project management to share and learn from each other. In 1994, the first edition of a guide to the project management body of knowledge, PMBOK, was published. The PMBOK describes the sum of knowledge within the profession of project management, including knowledge of proven traditional practices that are widely applied as well as knowledge of innovative and advanced practices. The project management framework is structured around 5 process groups that are made up of component processes consisting of tools, techniques, and outcomes, organized within 10 knowledge areas. These are the 5 basic process groups used to conduct a project: initiating, authorizing the beginning or ending of a project or phase; planning, ensuring that the objectives of the project are achieved in the most appropriate way; execution, coordinating all resources, people, and material during the implementation of the project plan; controlling, monitoring of project variances from what was planned to actual progress; closing, formal acceptance of the project or a phase and updating of the project information base with lessons learned. The process groups overlap with varying intensity during the execution of a project. A knowledge area describes project management knowledge in terms of its component processes. There are 10 knowledge areas: integration management, scope management, schedule management, cost management, quality management, resource management, communication management, risk management, procurement management, stakeholder management. The 10 knowledge areas represent the body of knowledge that a project manager must have in order to consistently deliver successful projects that meet a customer's expectations for scope, time, cost, and quality of the project deliverables. The project management framework consists of 10 knowledge areas presented on the vertical axis and 5 process groups organized across the top on the horizontal axis. At the intersection of the two, the framework presents the component processes, which are the project management processes that are common to most projects and the major deliverables produced by those processes. The new version of the PMBOK consists of 8 performance domains and 12 project management principles, which can be mapped back to the 10 knowledge areas and 5 process groups. One size does not fit all. True for projects, true for frameworks. Share. Share. Post. Share. Conference Paper Methodology, Organizational Project Management, July 14, 2002. Shahar, Aaron Dvier, Dov Leckler, Thomas Pauly, Michael. How to cite this article. Shahar, A. Dvier, D. Leckler, T. and Pauly, M. 2002. One size does not fit all. True for projects, true for frameworks. Paper presented at PMI Research Conference 2002, Frontiers of Project Management Research and Applications, Seattle, Washington. Newtown Square, Pennsylvania, Project Management Institute. Aaron J. Shahar, Stevens Institute of Technology Dov Dvier, Ben-Gurion University Thomas Leckler, Stevens Institute of Technology Michael Pauly, Stevens Institute of Technology. Introduction. One of the common myths and misconceptions about projects is that all projects are the same and you can use similar tools for all your project activities. We call this the project is a project syndrome, and it often leads to project failure and delays when companies are using improper project management techniques for some of their project efforts. While all projects have a goal, a budget, and a time frame, there is more to project management than just a few common elements. In reality, projects differ in numerous ways, and one size does not fit all. Yet, at present, only a few organizations know explicitly how to classify their project efforts and how to select the best approach to a specific project. And there is still no standard framework for distinction among projects and for selecting the right approach to the right project. This paper summarizes over 10 years of studies on the differences among projects and among project management techniques. Over the years, we have studied more than 600 projects and conducted over 1,000 interviews with project managers, line managers, team members, executives, project clients, and users. We have come to realize that project success depends not just on the traditional critical success factors, but also greatly on the proper project management style and on adapting the right technique to the right project. We have seen many projects fail because managers assumed that their current project would be the same as the previous one. Our research shows that in well-managed projects, project managers as well as top management are aware of project differences and use specific techniques and styles to manage different kinds of projects. However, our research also found that in most cases, companies and managers don't have a specific framework with which they distinguish among their project efforts. We realized it is time to develop a universal, context-free, and simple-to-use framework that will help managers and organizations start a project by assessing the project type and selecting an appropriate management style. The purpose of this paper is to propose such a framework and suggest guidelines on how to use it. However, in our work we realized that one framework does not fit all either, and that one would need different project classification systems for various organizational needs. This paper, therefore, includes a collection of frameworks for project classification. Some have been published in the past, and others are new and just emerging. We will start with some theoretical discussion, followed by the needs of different stakeholders for classifications. The main part of the paper will describe the various frameworks, and we will conclude by discussing who and how would use them. Initial theoretical and practical perspectives. From a theoretical perspective, one of the major barriers to understanding the nature of projects has been the little theoretical distinction made between the project type and its strategic and managerial problems, and the lack of specificity of constructs applied in project management studies. Although innovation studies have often used a traditional distinction between incremental and radical innovation, the project management literature has been slow in adopting similar approaches. Furthermore, while correlates of structural and environmental attributes have been well studied when the organization is the unit of analysis, they have been much less investigated in the project context. As mentioned above, the project management literature has often ignored the importance of project contingencies, assuming that all projects share a universal set of managerial characteristics. Yet, projects can be seen as temporary organizations within organizations and may exhibit variations in structure when compared to their mother organizations. Indeed, numerous scholars have recently expressed disappointment in the universal, one-size-fits-all idea and recommended a more contingent approach to the study of projects. As argued, by utilizing traditional concepts in a new domain, new insights will most likely emerge in this evolving and dynamic field. Our study attempts, as well, to address this theoretical gap. Who are the stakeholders that would benefit from a framework for project classification? It seems that different people would use such a framework for different purposes. For example, among other things, top management, CEOs, executives, and business leaders would look at decisions about portfolio management, aggregated returns, financial and business risk, and setting priorities. The marketing function, in contrast, would look for the impact of different projects on their marketing efforts, market research, and their ability to determine customer needs and product requirements. Similarly, the engineering manager would need a framework for distinguishing among difficulty and complexity of technical tasks, for assignment of technical experts, and for resources allocation. Finally, project managers would use a framework to determine their project structure, processes, and tools. They would also use it to distinguish among their design, testing, and verification efforts, and for the selection of team members and assignments of tasks. What framework would each one of them use and how, and would one framework suffice for all needs? As we show later, they would need more than one system, and they would use it in different ways. We turn now to describing the various frameworks and the specific project types in each framework. The frameworks. How to distinguish among projects. Strategic goal classification. This framework relates to the strategic business goal of the project. Different projects are initiated with different business perspectives and expectations. Some have longer-term business goals than others, and some are just for the short run. Some projects are for building infrastructure and capability for the future, and others are just exploratory in nature. We identified 5 different types of projects according to this categorization. Extension projects. These projects are extensions of existing products. They constitute improvements, line extensions, derivatives, cost reduction, upgrading, or feature enhancement. They are typically short-term, and their goal is to gain as much as possible from an existing product. They are considered as cash cows, which are aimed at extending the life of a product in the market. They would represent slight modifications or upgrades that are done in between major introductions of new products or new generations. Examples are in between years in automobile models or stripped-down models with less features and lower cost than the original product. Strategic projects. These are prime efforts that are made to create or sustain strategic positions in markets and businesses. Typically, strategic projects are initiated with a long-term perspective in mind. Their goal is to create a significant competitive advantage in the market and to establish leadership positions. Some see them as vehicles to create the basis of competition in their fields. Others just see them as necessary steps for sustainable survival and organizational endurance. In both cases, such projects are the backbone of organizations. They enjoy management attention and priorities, and their success or failure has a great impact on the organization's future. Examples are major automobile models introduction, PT Cruiser, new aircrafts such as Boeing 777, and such. Problem-solving projects. These get-hold projects are made to solve a specific problem that is needed in future endeavors. They do not produce a specific product, but produce a solution, which will be applied to future projects. They typically have a narrow focus and involve getting hold of a new technology that is needed for future products, creating a new capability in manufacturing, creating a new feature that would be added to several products, an effort of cost reduction that would be utilized in several future products, and so on. Such projects are relatively short-term, narrow in focus, and need moderate attention to just solve the problem. Utility projects. These projects are made to keep the lights on. While they, as well, do not produce any product that would be sold in the market, they are necessary for organizational survival. For example, such projects involve major maintenance efforts, new equipment procurement and installation, re-engineering, reorganization, or new software acquisition and implementation, such as ERP systems. Such projects may have low priority or slow time frames. They are essential to organizational sustainability and may consume extensive amount of critical resources. Research projects. This category includes all projects which are initiated for purposes of learning. They do not involve a clear product with a clear customer in mind. Rather, they are the company's investment in the future. In these projects, the company explores new ideas, creates new knowledge, or just pushes the envelope. Typically, such projects receive low priorities, and they often need to be separated. Otherwise, they are in danger of termination in face of quick and more urgent needs. Exhibit 1. The UCP model. The UCP model. In search for a universal, context-free framework for all project types, our research identified 3 dimensions to distinguish among projects: uncertainty, complexity, and pace. Together, we call them the UCP model, and they form a context-free framework for selecting the proper management style. See Exhibit 1. Uncertainty. Different projects present at the outset, different levels of uncertainty. Clearly, when a project is completed, everything is well known: the end result, the cost, the time, and the final specifications. Yet, as we have seen, uncertainty at project initiation is one of the major characteristics of any project. It determines, among other things, the length and timing of front-end activities, how well and how fast can one define and finalize product requirements and design, the degree of detail and extent of planning accuracy, and the level of contingency resources, time buffer, and budget slack. Project execution can therefore be seen as an ongoing process, which is aimed at uncertainty reduction. Failing to assess project uncertainty may result in excessive resources and unexpected delays. Uncertainties could be divided into external or internal and classified into several levels, as we show later. External uncertainty will have an effect on accuracy and predictability of customer requirements and on how to treat market research results, while internal uncertainty determines the process of product design, testing, and finalizing the specifications. Complexity. Complexity is the second dimension for distinction among projects. Management should realize that complexity and uncertainty is not the same thing. Imagine building a high-rise office tower in a major city. For this kind of project, even low levels of uncertainty may involve a highly complex collection of tasks. Project complexity is generally determined by project size, number, and variety of elements and interconnection among elements, and it may come from product complexity, but also from the level of organizational interaction. When it comes to managing different levels of complexity, the one-size-does-not-fit-all rule will affect project organizational structure. the hierarchical level of the project manager, the formality with which the project is managed, the extent of subcontracting and outsourcing, and the degree and tightness of project control. Pace. The third dimension of the UCP model involves the speed and criticality of time goals. Obviously, no project is free of limitations, and time is one of the major constraints. However, as we found, the available time given for project completion and the degree of urgency is an important factor for distinction among projects. The same goal with different timeframes may require different project structures and different management attention. The highest-paced projects are the most critical in terms of time of product introduction. The higher the pace, the closer is project monitoring, the more autonomous is the project team, and the higher is management involvement. The sources of project risk. Obviously, no project is risk-free, but various projects have different levels of risk. The three dimensions for project distinction create, together, a risk assessment and management framework. The most risky projects are those of highest uncertainty, highest complexity, and highest pace. How can organizations apply this concept as a practical tool for better understanding of the nature of projects and for adapting the proper management style? In the following sections, we operationalize project classification along the three dimensions to describe typical project management styles and integrate different risk levels. The categories we use emerged in our studies as the most common types of project styles. Since, in general, most projects do share things in common, we will focus, for each category, on the unique features of project management characteristics. What is different, and what should management be aware of? Market uncertainty, external. External uncertainty represents factors that are beyond the immediate control of management or project team. The major source of external uncertainty is the market, where three levels of uncertainty can be identified: derivative, platform, and breakthrough. Other sources, however, may involve political, economical, or environmental issues. Market uncertainty is associated with accuracy and confidence, in which one can define the end product, the what needs to be done. To define market uncertainty, management should assess: how new is the product to the market, and how well do customers or users know about it? Different market uncertainties require different techniques for market assessment, market research, market feedback, and thus product definition. It will affect the involvement of marketing in product development and the cross-functional interaction between marketing other departments, such as engineering. When Sony considered introducing its first Walkman, the product presented a new concept to the market. Market research proved inconclusive, and the decision to launch was based on managerial intuition. The first prototype was tested as soon as possible in the market, and product introduction was then followed by fast market response, which was relayed back to engineers for immediate product modifications and development of derivatives. And similarly famous 3M Post-it notes did not get much appraisal from marketing predictions. Only after initial market testing did the product create its reputation to become the greatest success in the history of office supply products. Wheelwright and Clark used three major new product categories to manage the company's product portfolio and to create an aggregate project plan. These categories represent different levels of external uncertainty and determine management behavior regarding marketing of new products and their impact on project management. Derivative projects. These projects include cost reduction, product improvement, and additions to existing lines. Previous products are well established in the marketplace and market data is readily available. The what-to-do question is relatively easy to answer. Predictions about product cost, as well as other product requirements, can be fairly accurate, and there is no need for market experimentation. Product requirements must therefore be fixed as early as possible, most likely at project launch, and design should adhere to these requirements to ensure fast execution for a timely completion of the project. Platform projects. These projects exhibit new generations in existing product lines. They create a new family of products to form the basis for numerous derivatives. Such products replace previous products in a well-established market sector. Although some platforms may involve completely new technologies, product usage by customers can be predicted fairly well. New combat aircraft designs or new automobile models are typical platform examples. Market uncertainty is obviously higher than in derivatives. For these projects, companies should perform extensive market research, study data of previous generations, and make careful planning of product price. The final setting of product requirements will therefore take much more time, and it should be planned well into the project execution period. However, there is a trade-off. It should not be delayed too long to ensure timely product introduction and reasonable profitability. Breakthrough projects. Introducing the first Post-it notes or the first Walkman were just two examples of breakthrough projects. So were the first personal computer, the first microwave oven, or the first internet browser. Breakthrough products may use new or mature technologies, but in each case the market does not know anything about the new product, nor do customers know how to use it until they see it. Market studies are therefore, to a great extent, ineffective, and product definition must be based on guessing, intuition, and market trial and error. Requirements must remain flexible until first market introduction is possible and until customer feedback is available. Fast prototyping is necessary and is much more critical than extensive market research. Since no one can predict market actual response or customer preferences, changes in initial product specifications are inevitable, and while clear product definition is perceived to be critical to any project, management of breakthrough projects must realize that product definition will most likely change in time after initial market trials and feedback from early users. Technological uncertainty, internal. The major source for internal uncertainty is technological uncertainty. Other types may involve team experience or tight budget constraints. Higher technological uncertainty at the time of project initiation requires longer development phases, more design cycles, more testing, and later design freeze. In general, we associated such uncertainty with the degree of using new, to the company, versus mature or well-known technology within the product or process produced. In our studies, we found 4 distinct levels of technological uncertainty, which matched 4 different project management styles. Type A, low-tech projects. Low-tech projects are those projects that rely on existing and well-established technologies. The most typical examples of such projects are construction, road building, or build-to-print cases, where a contractor is required to rebuild an existing product. Projects in this category require no development work. Their architecture, design, and resource planning are all carried out prior to the project's implementation phase. Such preliminary work typically results in detailed plans, specifications, drawings, and material lists. In such projects, the product is entirely shaped and the design frozen prior to the project's formal approval and the inception of the implementation phase. Management style in such projects must be firm, since profit margins are typically slim given the low level of uncertainty. Project managers should therefore stick to the initial plan, with a no-nonsense, no changes, and get the job done attitude. Type B, medium tech projects. Medium tech projects use mainly existing or base technologies, yet incorporate some new technology or a new feature that did not exist in previous products. Examples include improvements and modifications of existing products, derivatives, but also new generations of products and industries where technology is relatively stable, such as major appliances, automobile, or heavy equipment. Although most of the technologies used in this kind of projects are not new, the project, nevertheless, will involve development work and testing activity. In general, however, some changes would be added to the initial design, but they should be confined to a limited period, and the design should be frozen quite early, typically after 2 cycles. While still firm, management style could be more flexible since some changes and adjustment in design are needed. No changes and improvements should be allowed, however, once the design was frozen, with an exception of safety or hazardous reasons. The policy and attitude could be limit changes to minimum and freeze as early as possible, but not too early. In an attempt to save time, some companies are using collapsing methods or overlapping of project phases. Typically, it involves starting manufacturing activities or ordering production parts even before product development is completed. This will work best in Type A or B projects, but should be exercised cautiously in higher levels of technological uncertainty as we show later. Type C, high-tech projects. High-tech projects are typical to situations in which most of the technologies employed are new, but nevertheless exist when the project is initiated. Such technologies had been developed prior to project inception, and a Type C project probably represents the first effort to integrate them into one product. Most defense development projects belong to this category, but also new generations of computers and other products in the high-tech industry. Incorporating new technologies for the first time typically leads to products that did not exist in the past, and as we found, execution and management of high-tech projects is entirely different than of medium-tech and low-tech type. They are characterized by long periods of design, development, testing, and redesign. Projects of this nature require at least 3 design cycles. Design freeze must be scheduled, therefore, to a much later phase, normally during the second or even the third quarter of the project execution period. And management style must be much more flexible in these projects since numerous designs must be tested and will lead to changes and improvements during much longer periods. Type D, super high-tech projects. These projects are clearly distinguished from Type C. These projects are based on new technologies that do not exist at project initiation. While the mission is clear, the solution is not. This type of project is relatively rare and is usually carried out by only a few, probably large organizations or government agencies. One of the most famous examples of this type was the Apollo moon landing program. At project inception, it had a well-defined mission and timetable, but no available technology was at hand, and nobody really knew how to get to the moon. Unlike previous, lower uncertainty type projects, a great deal of the effort in this type is devoted to the development of completely new technologies and to testing and selecting among various alternatives. As our studies found, projects in this category use similar techniques to resolve the issue of unknown technologies. They institute an intermediate program to build a small-scaled prototype on which new technologies are built and tested. Type D projects thus require extensive development periods, very late design freeze points, and intensive management of ideas and change until the final configuration is selected. Management style must be extremely flexible, yet cautious. The attitude in these risky projects must be, look for trouble. It's there. If you don't see it, you have not looked enough. And since things change so fast, extensive communication is essential among project teams and team members. The formal system of reporting could simply not accommodate the degree of new information that is created, and the formal documentation is normally slow and normally too late to record the latest changes. Needless to say that collapsing project phases is even more difficult, and later phases cannot start until previous project phases have been completed and approved. System scope, project complexity. In our study of different project complexities, we observed 3 typical management styles. They are distinguished by the way the project is organized, its sub-elements are coordinated, and the extent of formal versus informal interaction and documentation. Higher complexity will require more advanced and far-reaching organizations, increased formality in managing and coordinating project activities, and more documentation. As we found, a simple way to define and distinguish among different levels of complexity is to use a hierarchical framework of systems. We call it system scope, and in most cases, a lower scope level may be seen as a subsystem of the next higher level. Project management practices can be compressed to the following typical 3 levels. Level 1, assembly projects. Assembly projects involve creating a collection of elements, components, and modules combined into a single unit or entity that is performing a single function. Compared to the higher levels, assembly projects are relatively simple. They may produce a standalone product such as a CD player, an overhead projector, or a coffee machine, or create a subsystem of a larger system such as a computer hard drive or a radar receiver. They may also involve restructuring a functional organization or building a standalone service. Assembly projects are typically carried out by a single organizational function or a small cross-functional team, often within one organization and with a low level of formality or bureaucracy. The number of project activities or subtasks is normally in the range of tens, and as we learned, the planning of budget and schedule in this type of project is simple, requires only basic tools of project management, and is often done manually. Interaction, communication, and much of the decision-making is, to a large extent, informal and is carried out among people who know each other well and meet each other almost daily. Documentation and reporting is minimal and is often carried out only after the main activities are performed and finalized. As a result, administrative staff within the project team is minimal, with most of the administrative work done by the technical performing staff. Level 2, system projects. Systems involve a complex collection of interactive elements and subsystems, jointly dedicated to a wide range of functions to meet a specific operational need. System projects may produce aircraft, cars, computers, or buildings, but may also involve re-engineering efforts of entire businesses. System projects are typically led by a main contractor or program office, and the total effort is divided among numerous subcontractors, some in-house and some external. The program office is responsible for the final integrated result and for meeting overall performance, quality, time, and budget goals. Such projects are managed in a more formal way than assemblies, with extensive documentation and contracting between main and subcontractors. One of the major problems encountered in system projects is total system optimization and system integration, particularly at the medium, high, and super high levels of uncertainty. In system projects, the successful execution of separate subunits and the optimization of each one of them is one thing, while integrating them into a one working and optimal result is another. Problems of interface, interference, energy dissipation, and even lack of space usually require a long process of assembly, testing, and trade-off. Experienced system providers will make sure their schedule includes a long period of system integration with several cycles until the entire system is optimized. Since most system projects extend beyond organizational borders and require substantial outsourcing and contracting, they usually employ special administrative staff as part of the project team. Such staff people will handle the planning, budget management, contracting, and controlling issues, and free the technical staff to do the work of design, building, and testing. System project tools are also more complicated than those used on assembly projects. The number of project activities is in the range of hundreds and maybe up to a few thousands. While there are many existing project management tools and applications, system projects and their corporations often find it necessary to develop their own tools and documents to meet their specific requirements. Level 3, Array Projects. Arrays deal with large, widely dispersed collections of systems, sometimes called supersystems, that function together to achieve a common purpose, such as city public transportation systems, national air defense systems, or interstate telecommunication infrastructures. Arrays are clearly large-scale projects, yet, in most cases, they do not involve building the supersystem from scratch. Rather, such projects often involve gradual growth, addition, or modification to an existing infrastructure. Notable array projects of recent years were the upgrading of the New York subway system in the early 1990s, the preparation of the city of Atlanta to the Olympic Games of 1996, and building the English Channel Tunnel. Array projects require the administration of many separate programs, each one devoted to a different component or system. Projects are typically organized in the form of a central umbrella organization, which is set up as a separate entity or company and is formally and legally coordinating the efforts of numerous sub-projects in other organizations. The actual technical work is executed, however, within the sub-organization. Success in such projects depends, to a large extent, on the proper bureaucratic system set up to manage and coordinate the program. The focus is on extensive documentation, contracting, and tight financial controls. The dispersed nature of the end product and the extent of subcontracting makes it necessary to manage these programs in a highly formal way and to put a lot of effort into the legal aspects of the various contracts. Ordinary tools of planning and control are even less relevant here, and management must often develop its own system of contract coordination and program control. Yet one issue is probably less critical here: system integration. Since most elements are add-ons to the entire system and many projects involve infrastructure building, add-ons do not normally cause the same level of interference as in tightly built systems. The Internet, for example, was originally built in the 1960s as a network connecting academic and government labs. It gradually evolved to the global phenomena of the World Wide Web, extending national borders and early visions. No single project could probably have planned it all in advance and integrated at one time. Project pace. How critical is your time frame? Criticality of meeting time goals and consequences of failing to do so is associated with project pace. While in reality, project delays are more common than not, on this scale projects will differ by how much time is available and what happens if the time goal is not met. We identified 3 different types of pace: regular, fast/competitive, and critical/blitz. Regular projects. Such projects are typically carried out by organizations to achieve long-term or infrastructure goals. They include public building works, road building, organization improvements such as re-engineering, and technology build-up efforts. Although they are scheduled for completion on a certain date, missing the deadline is in fact being tolerated, since time is not critical to immediate organizational success. Unless specifically prioritized, such projects are managed in a relatively casual format and may often be delayed or pushed aside by more urgent critical assignments. While hard to admit, such projects exist and are an inseparable part of the spectrum of project management landscapes. A famous example of this type of project was building the Sydney Opera House in Australia. When commissioned, the original schedule assumed 6 years of construction. With no real pressure and city political changes, the building was finally completed in 1990 after almost 16 years of stops and starts. Today, it is one of the best tourist attractions in Australia, and no tourist will come to Sydney without visiting at the Opera House. The lesson is clear: with no external or enforced pressure, such projects will always take longer than planned. Similarly, re-engineering efforts are normally not affected by direct market pressures of meeting the deadline of time-to-market introduction. Unless real pressure comes from the top, other priorities are sometimes winning. In fact, many re-engineering projects have gone nowhere for the lack of time pressure and commitment. Fast/competitive projects. These are the most common projects carried out by industrial and profit-driven organizations. They are typically conceived to address market opportunities, create a strategic positioning, or form new business lines. Time to market is directly associated with competitiveness, and although missing the deadline may not be fatal, it could hurt profits and competitive positioning. Fast/competitive projects must be managed strategically. Project managers should focus on meeting schedule, but also achieving profit goals and addressing market needs. Managing the time frame should be one of the main concerns, and top management must support and closely monitor these projects at their major milestones, yet also be alert if something goes wrong in between milestones. Critical/blitz projects. These are the most urgent, most time-critical projects. Meeting schedule is critical to success, and project delay means project failure. Such projects are often initiated during a crisis situation or as a result of an unexpected event. Examples may be industrial projects set up to leapfrog a surprising move by competition, or military projects that address a timely problem during wartime. September 11th created numerous projects of this kind. Similarly, although the problem was expected years in advance, many Y2K projects became critical as December 1999 approached. Yet to succeed, such projects must be managed completely different. The workflow in these projects is very tight. It is performed almost around the clock, with nonstop interaction and continuous decision-making. There is normally no time for detailed documentation or report writing. So is the rest of the bureaucracy, limited to minimum. Project managers in critical/blitz projects must possess high autonomy, where project organization could be nothing less than a pure project structure and all team members reporting directly in the chain of command to the project leader. Sometimes this form is called skunkworks. And top management must be there all the time to support and continuously monitor project progress. Without such commitment of all parties, blitz projects could not be launched successfully. Yet don't forget, a single organization cannot embark on too many of those projects. One or two, at most, can be carried out at the same time since critical/blitz projects are hurting the rest of the organization. Drawing important resources from other fast/competitive projects and alienating excellent project managers who do not enjoy the extent of commitment and priority of the blitz project. Using the different frameworks. Who would use these frameworks and how would they be used? As our research shows, each one can be used in a different way and by different stakeholders. The following exhibit summarizes the different models and their use. Summary. In this paper, we have shown how an organization can identify differences among projects and how to classify projects according to different dimensions and frameworks. The results accumulated over a period of a decade of research. Some of it was published in the reference papers. However, in conclusion, one should remember 2 points. First, the research is not over. With time, one should expect that additional and better frameworks would emerge. That is particularly true in the current age of global wireless and internet world, or the emergence of biotechnology as the next possible revolution after the information revolution of today. Second, while these frameworks are quite universal and may serve many needs, any organization wishing to implement a framework for project classification should look at its own situation and adapt some of these frameworks, while maybe developing its own way for project classification, which will better fit its structure, strategy, and culture. Acknowledgement. This research has benefited from the support, advice, and ideas of many individuals and organizations. The National Science Foundation provided support for the study of commercial competitive projects. In addition, various levels of support were granted by the Institute for Business Research at the School of Business at Tel Aviv University, the Center for the Development of Technological Leadership at the University of Minnesota, and the Center for Technology Management Research and the Alliance for Technology Management at Stevens Institute of Technology. Finally, the Ministry of Defense in Israel provided resources and important access for the study of defense development projects. Exhibit 2. Summary of Frameworks for Project Classification. Initial drafts had benefited from ideas by Alex Laufer, Zeev Bonin, Michael Duby, Dov Eden, Simcha Ronen, Avi Niergrosfeld, Boaz Ronan, Shlomo Globerson, and Peter Kuhn. Ofer Levy helped in the development of the Success Dimensions framework. Many other students have also contributed to this study, among them Michael Peled, Shlomo Klein, Scott Frick, Ziho Gray, Alagerward, Paula Richards, Brian Cohn, and Brian Knopfsinger. Max Weidman was a thought-provoking partner in developing the Work Breakdown Structure Risk Assessment Framework. Finally, several members of the Project Management Institute, PMI, group on project classification organized by Greg Githens and Brian Cohn suggested helpful and insightful comments on previous portions of this work. To all of them, I am deeply indebted. Introduction. Nowadays, we see many discussions between the project management community and the Agile community, often focusing on Agile versus traditional. We prefer to call them waterfall or linear approaches. In the project management community, we hear ideas like Agile is only a hype, it will pass, or we've been doing this for many years, or this is only useful for IT. In the Agile community, we hear, in Agile we don't need project management, or project management is only about command and control, or project management is not relevant to Agile. As project managers, we have a tendency to gravitate towards a particular method or approach. We often learn and practice specific disciplines and use particular tools and techniques, and over time this becomes our default way of working. It also becomes our worldview and perspective, and in doing so, creates a frame of reference that we use to judge what we believe is the best way to do things. Irrespective of whether we are strongly rooted in IT or another discipline, or are strongly rooted in Agile or linear project management, each of us can acknowledge that there is more than one way to manage change successfully, and that given the nature of the change, we should use the most appropriate approach and tool for the job. Sometimes this may be an Agile approach, and in other instances it may be traditional project management. It all depends on the circumstances. However, some people take the view that either an Agile approach has no place or that traditional project management doesn't work. We have ample experience that basic misconceptions are the root cause for these ideas, that they are, in fact, keeping us from developing better and stronger ways to enhance project success, thereby delivering more value to our customers, which is arguably why we do what we do. We don't just believe that Agile development is the Agile PM is a registered trademark of Agile Business Consortium Limited copyright 2018 Agile Business Consortium Limited way to develop. Nor do we believe exclusively in project management. We believe that, in the end, the key to success is people cooperating and interacting to provide customer value, and these people must be facilitated by processes, tools, techniques, governance, etc. to be more successful. VUCA world. The world is becoming more VUCA, volatile, uncertain, complex, and ambiguous. Volatile in that what is important is changing all the time. Uncertain about what the correct way forward is. Complex in that solutions are not straightforward and depend on and are influenced by many often interrelated factors, like chaos theory. And ambiguous in that there is no consistent right or wrong way. That is, it depends. The VUCA world is not everywhere, not all the time. For building bridges, the world is still usually a relatively stable place. But for the development of products and services, there is more uncertainty. Customers change their minds, often for very good reasons, and are often also influenced greatly by peers and the media. The truth is ever more difficult to find. Is an electrical car good for the environment or bad for the environment? Actually, it's both at the same time. How ambiguous is that? In such a world, a major risk is doing full, detailed analysis up front to define the perfect solution for a problem that no longer exists. Experience has shown that to be successful in a VUCA world, organizations need to be radically customer value focused and deliver added value regularly, reliably, and flexibly. Success is based on embracing change and constantly adapting to changing circumstances. The days of the laminated 3 to 5 year plans are history, as the plans that are developed are out of date before execution started, and even potentially out of date before the laminate has cooled. Not all projects that are executed in a VUCA world seem to embrace this viewpoint, which is one of the reasons why these projects are not successful in the end. Small incremental change is very useful for delivering IT systems, but when delivering other types of solutions, change usually has a higher impact. For instance, when delivering a security system for a subway or a new baby formula for a specific market, change and implementation is much more complex. These kinds of solutions have been successfully delivered using agile approaches, and one could argue that, with proper project management, agile ways of working could be successfully adopted in many more sectors to deliver more business and customer value. More and more non-IT solutions are successfully delivered using agile approaches, where the organization can iteratively develop and learn and incrementally deliver value and decrease risk. When running projects in relatively stable environments, planning can be done using previous successful projects. Within margins, the projects are comparable. The less a project resembles another project, the more difficult planning becomes. And in a VUCA world, where at the start we don't know what we will end up with, it is even more difficult to plan. Through their research, economists Lovello and Kahneman identified that people are generally poor at planning and estimating, and in doing so, identified that a planning fallacy exists. That is, planning and estimating when you execute a certain task for the 10th time is easier than when you do it for the first time. Planning and estimating what you will do today or this week is simpler than planning and estimating what you will do in 3 months' time. So, within the modern world, we have to expect and accept that planning the full project over a long period of time will not work. However, planning for very short periods of time and delivering customer value regularly allows for testing assumptions, for learning, and results in only running small risks. This does not negate the need for longer-term plans. These still exist in Agile, but the plans covering a longer time frame should contain limited detail and focus on the big picture items. Agile Manifesto. More and more organizations use Agile methods or frameworks to develop and deliver solutions. Whilst the term Agile was first defined in the field of software delivery, it has proved to be equally effective in other areas. The Agile style of working started long before the word Agile was defined in a workshop in Utah in 2001. At its heart, Agile is about being pragmatic, flexible, and using common sense. Which, of course, is also why many people claim it is nothing new. For many organizations, this has always been their natural style. The Agile Manifesto, www.agilemanifesto.org, has 4 values and 12 principles. See Figure 1. Quick note, this manifesto and the values are targeted towards delivering solutions, or, when it was written, developing software. None of it refers to how to manage the delivery. An example of developing a new product for a specific segment of the market, using an agile and a linear approach using a linear, waterfall-based approach. The product development team would conduct market research to determine the needs of the customer and identify the potential problem that the product can solve or need it will meet. In some instances, there is little effort expended in market research with a series of untested assumptions being made instead. The team then starts designing and building the product and then launches the product into the market, only to find that the product is not really what people want, need, or can use. Customer feedback, which often comes in the form of a lack of sales, is then taken on board and the design and development of next version of the product is undertaken. This is fundamentally a large batch approach where the product is delivered in total, at the very end of the process, often after a protracted period of time. Each subsequent version of the product is then delivered after an equally long period of time. Using an agile approach, by comparison, the product development process would start with some market research, in the same way as the waterfall approach above. However, it is at this point things significantly differ. The product team design and build a small, limited functionality product known as a minimum viable product, MVP, to test the market assumptions and to also validate the research and customer needs and demands. Through market and customer feedback, a series of versions is incrementally developed and released. This approach is a small batch approach with a series of smaller and more frequent releases. It is based on a rapid process of building, measuring, and learning. The measuring and learning steps are critical as they allow the product development team to adapt and adjust in each successive iteration. With agile ways of working, organizations adopt small, focused, self-directed, dedicated teams, visual management, the ability to adapt to change, learning explicitly incorporated in the delivery cycle, prototyping, failing fast, drumbeat-paced incremental delivery of business value, and more goodies. These are all good things. However, when starting or continuing their agile journey, one thing organizations should be very careful about is to focus on what they want to achieve and why. Do you embark on the journey to become more customer-focused, to speed up your delivery process, to align your organization, to ensure more quality? Knowing why you want to improve something helps to define the next step of the journey and safeguards against blindly follow the handbook because that's what we've decided. Maintaining focus on the why is key. When the world in which the organization operates is more VUCA, agile delivery is better suited than the linear think, analyze, build, deliver. Success is not guaranteed by thorough in-depth analysis up front, but rather by enough design up front and by the customer accepting the added value incrementally. Delivering change organizations in the private and the public sector are, or should be, focused on delivering increasing customer value. This results in renewing, improving, or changing the offer to the customer continuously. Change is the new normal. Just delivering the same value for a long time is no longer acceptable, not in the private sector, not in the public sector. We see three types of change: continuous or incremental change, transitional change, and transformational change. Of course, this is a gradual scale, but let's have a look at these changes. Change can be continuous or in small increments, based on relatively stable solutions and a relatively stable situation. Examples are adding new features to a stable system, adding a new layer of paint on a house, improving the performance of a car by adding a new exhaust system, and having to change the settings of the ignition, changing the operating system on a phone or computer. These changes do not require a big change in the usage, nor do users have to be trained. The organization's processes just require minimal adaptation. In other words, it's business as usual. This style of change does not typically require the discipline of a project, something with a beginning, a middle, and an end. Change can be transitional. The status quo is changed. Processes need to be adapted or new processes defined. New products are delivered in old markets or old products in new markets. Examples are a new roundabout, a fully new user interface, changing the place of the kitchen in the house. Changing the way things work, usually using training, needs to be part of the successful delivery of the change. Or it might require the organization to shift to a new mode of operation. This is what we call transitional change. It is a transition from a relatively stable situation to the next relatively stable situation. Delivery is done with customer involvement. Projects and programs are common in this space. The project to deliver the solution, hopefully in an iterative and incremental way, and the program to coordinate the changes in the most effective way. And then change can be transformational. Disruptive change is the trendy word for it. Examples are a new product to a new market, building a new energy-neutral house on the South Pole, becoming the world's first energy-neutral city. Unpredictable. Learning as you go. Trial and error. Learning while you're developing. Values change. Transformations can be initiated by new technology, by societal change, by threatening disasters. However, disruptive change does not always end well, despite the hype in seeing disruption as a good thing. Agile PM is a registered trademark of Agile Business Consortium Limited, copyright 2018. Agile Business Consortium Limited. Typically, transformational change may still need to be based around projects, programs, and portfolios, and because of the inherent uncertainty, volatility, ambiguity, and complexity, using an Agile approach here is highly beneficial and, in reality, offers the best chance of success. It will help support and embed ongoing learning. That is what an Agile approach is all about. Approaches to the different types of change in a stable incremental change environment. An organization can use factory-type approaches. In banking, we see software factories, safe/less frameworks, etc., which adapt standard line management for facilitating the Agile delivery framework. Also, we see lean approaches and theory of constraints ensuring day-to-day improvements to the processes, removing unnecessary work, and increasing value delivery to the customers. Usually, only complex changes in an environment like this require project or program management. To deliver customer value at scale, the delivery has to be carefully managed and not just left to chance. In a transitional corporate change environment, project and program management may be more appropriate. Agile development approaches fit very well in this environment because of their openness for learning and change. Regular project and program management approaches need to be adapted for facilitating the Agile delivery framework if this is used. In a transformational corporate change, crisis, or turnaround, approaches may be used for negative cases. Startup and scale-up approaches will be used in the positive cases. An Agile development approach can be helpful. Project management will only help for those parts of the change that are more transitional than transformational. In general, however, it is important to remember it is not methods that deliver change. It is competent people that deliver change, supported by methods, processes, tools, and decision structures. Individuals and interactions above processes and tools. Agile project management. Agile is all about empowered self-organizing teams of professionals regularly delivering value to the customer. In a simple situation where objectives are clear, where the environment of the team is stable, where the team or organization is small, where the customers know how to use the solution without extensive training, then project management may not be needed. Small teams are able to disperse the management competencies amongst themselves, hence become self-steering. In some organizations, for delivery of solutions in a business-as-usual, incremental change situation, a project-based way of working was, or is, used. In those cases, continuous improvement, lean approaches might be much better suited. Project managers are not useful in these situations. Project management competences in such a situation are taken up by product owners, scrum masters, tribe leads, etc., etc. However, if the situation is more complex, management is needed to organize the many interactions and to provide direction in the event of changes that occur outside the project. Often this management keeps the environment as simple and balanced as possible so the teams can deliver. This is the role of management within an Agile delivery framework, to facilitate the delivery team, those that are delivering the value. Management facilitates the delivery of business value, ensures the engine keeps running at optimal speed, and steers the vehicle towards optimal value. Whilst management may be considered an overhead, it is useful if it provides the environment for teams to deliver. It may even be necessary where strict governance is required due to regulatory requirements. In this environment, and to get the best out of an empowered team, a facilitative style of management is key. A command and control style will stifle the team and limit the value to be gained from their collective knowledge and experience. When scaling up an Agile delivery framework to a corporate scale, the need for coordination and communication is vital. Fast decision-making, Fast and transparent communication and negotiating interfaces become of utmost importance, especially when there is flexibility in the delivery process. And because the organization is continuously learning, the framework needed for communication and decision-making has to be adaptive as well. All decisions are valid until new information and learnings create a better one. Again, Agile. Project management competencies help deal with the ongoing volatility. For transitional change in a project environment, simple Agile development methods typically don't provide. Agile PM is a registered trademark of Agile Business Consortium Limited, copyright 2018. Agile Business Consortium Limited, help for embarking resources, managing budgets, managing risks and issues, or delivery against specific milestones. Even more importantly, the impact of change might be neglected. For transitional change, someone needs to carefully engage with stakeholders and manage expectations around what will be delivered when, and often also has to explain how the solution will be developed in lay terms. Project management competencies are needed here. Project management competencies, therefore, are needed to create and facilitate the right environment for the teams to deliver transitional change. These might be delivered in any role, or split over many roles, or combined in one person, and the role might have any name. Of course, project manager would still do. The project management style for Agile needs to be supportive, empowering, facilitating, communicative, holistic, and cooperative. Far from the command and control, risk-averse, divide and conquer, communication on a need-to-know basis style some people attribute to project managers. Delivering several types of changes. Many organizations deliver transitional change and incremental change at the same time to their customer base. In such cases, the organizations need to keep track of investments, risks, and resources to deliver customer value. Tracking the change portfolio needs to be adaptive and focused on customer value, facilitating the initiatives to adjust to changing needs as fast as possible. Unfortunately, many organizations have adopted a portfolio management approach, which does not allow for speedy, adaptive decision-making. Rather, quarterly decision-making based on extensive reports is used. It goes without saying that in such an environment, it is difficult for initiatives to deliver value. In other organizations, different portfolios are used for incremental change and transitional change. In such cases, we regularly see that customers are overloaded at some times and at other times do not get value. Or we see that incremental value already delivered to the customer is overridden by a transitional change. Using Agile portfolio management supports the project teams and delivery teams to stay focused and deliver. Conclusion: just because you use an Agile development approach doesn't mean that project management is not necessary or is no longer required. Some Agile coaches suggest that project managers are not needed, arguing that the Scrum Master, or even the product owner, does the job of the project manager. And in a relatively stable environment, delivering relatively small changes, they are right. In the same way, managing smaller, more simple projects using traditional project management may not be the most efficient management approach. However, when delivering transitional change in a VUCA world, we argue that project and program management competencies are needed to consistently deliver customer value. Project and program managers performing this role should be fully aware of the Agile mindset and the style needed to support the Agile delivery teams. This mindset also applies to line management. When needed, the style of management needs to be adapted to an Agile delivery process. Agile encompasses a way of working, a delivery method, a mindset. Despite the first Agile value being, we value individuals and interaction over processes and tools, in reality, we encounter many organizations focusing on implementing Agile processes and techniques. Becoming more Agile is a never-ending journey in which people, in teams, are constantly learning how they can provide more value to their customer. Management is there to support them in this journey. And when implementing more complex change, management is needed. Agile PM is a registered trademark of Agile Business Consortium Limited, copyright 2018. Agile Business Consortium Limited. Project management is also a way of working, a way of planning and managing, focused on delivering change successfully. We see many project managers focusing on process rather than on facilitating people, customers, stakeholders, and teams. We also see organizations that, in order to overcome the challenges of operating in a VUCA world, try to simplify and control their environment. Rather than developing capabilities to sense and adjust to the inevitable changes that will occur, they attempt to control and restrict these changes and often increase the processes and procedures that need to be used, or attempt to plan in ever-increasing levels of detail. In doing so, they become even more risk and change-averse. This approach will never lead to success, nor to optimum delivery of value to the customer. It will lead to controlled failure. Embracing flexibility, adaptation, and constant change to provide customer value is difficult but necessary to deliver in the VUCA world. We strongly advocate that the best of the Agile techniques and mindset, combined with the best of the Agile project/program management techniques and mindset, will help small and large organizations to increase the success of delivering value to customers for every type of project. And as we have stated before, customer value is delivered by collaborating, competent people in teams. Methods, tools, techniques, processes are all necessary to facilitate these people to actually deliver. Agile project management. A mandate for the changing business environment. Share. Share. Post. Share. Conference paper Agile. Change Management, Stakeholder Engagement, October 19, 2008. White, Karen R. J. How to cite this article. White, K. R. J. 2008. Agile Project Management, a mandate for the changing business environment. Paper presented at PMI Global Congress 2008, North America, Denver, Colorado, Newtown Square, Pennsylvania, Project Management Institute. Abstract. Industry news is buzzing about how agility is required to succeed in today's economy. Industries including automotive, consumer goods, retail, even construction have realized that just-in-time inventory and build-to-order are management approaches that can assist market position and market value. Yet, these industries still use a more traditional approach to manage crucial and time-sensitive projects. This paper explores how project managers, program managers, and the Project Management Office, PMO, can introduce nimbleness and speed into current project management processes and provides an approach to determining if Agile project management should be applied to a project along with some techniques to overcome the organizational resistance that can be anticipated. Introduction. Despite the industry buzz about the need for agility in today's economy, many industries continue to use a more traditional approach to manage the very projects that enable agility in their core businesses. Organizations have invested in the development and adoption of project management techniques, including PERT and earned value management, since the days of World War II. In the economies of that big business era, an emphasis was placed on quality and doing it right. This translated into processes that were hierarchical and rigid in nature, with an emphasis on serial phases and permission gates between phases. As a global economy started to evolve, new management techniques, such as concurrent engineering, entered the marketplace. Today, doing it right is no longer good enough. Corporations must now also get it done rapidly. Consumers' desire for speed has transformed business behaviors. If a corporation cannot quickly respond to a market need, that need will be fulfilled elsewhere, perhaps outside the local economy. Project and program managers leading critical initiatives need to understand and appreciate these business pressures and be ready to adapt their processes accordingly to be more agile. Society underwent a paradigm shift in the latter part of the 20th century with the emergence and acceptance of the Internet and its associated technologies. Consequently, we are approaching the state of a single global society and economy, or, as Thomas Friedman, 2005, called it, a flattened world. This shift impacts the way businesses approach the management of projects. Organizations and project managers need to be ready to respond with tools and techniques such as agile project management. Much is being written these days about the need for agility in business, especially in information technology and in projects related to developing corporate differentiators. Yet, it's questionable whether there is a true appreciation for what is meant by the term agility. To the dismay of some managers, agility does not mean unmanaged or undocumented. Rather, agility means the ability to quickly adjust and respond to changing business needs. Definition of agility. The word agility is derived from the Latin agere, means to drive, act, implying a sense of ownership and the ability to drive something forward. Other definitions mention ready ability to move with quick, easy grace. So it is also associated with the quick and easy changes of direction and form called for by today's business environment. Additionally, the definition refers to having a quick, resourceful, and adaptable character. Economies started to evolve. New management techniques, such as concurrent engineering, entered the marketplace. Today, doing it right is no longer good enough. Corporations must now also get it done rapidly. Consumers' desire for speed has transformed business behaviors. If a corporation cannot quickly respond to a market need, that need will be fulfilled elsewhere. So, agility has 3 characteristics important to project management in this new business world. Sense of ownership and authority. Quick and easy changes of direction and resourceful and adaptable. Agile project management. Now let's take those attributes defined previously as agility and apply them to the practice of project management as we know it. For purposes of clarity, I will use the term traditional project management (TPM) to define the project management techniques predominant today, that is, the method focused on centralized decision-making and control within a hierarchical organizational structure. TPM has been proven successful in projects whose solutions can be relatively defined, scoped, and estimated, both time and cost, such as most construction projects. However, today's business projects likely have high degrees of unknowns and uncertainties associated with them, especially when viewed in the global economy. Many project managers would suggest today that it is nearly impossible to document all requirements, even at a high level, at the beginning of any project, given the speed of economic dynamics. Only after product development commences does the customer begin to realize that what they needed is not exactly what they requested. The cost to business and consumers for this behavior is immense when projects are not completed satisfactorily, with missed schedules and cost overruns. An approach that deals with the reality of continuous change, or which incorporates discovery and learning throughout the project lifecycle, must be utilized instead. That approach is Agile Project Management. Agile Project Management versus Agile Product Development. Introducing agility into your projects does not mean replacing your current processes. Agile Project Management is a new and better way to handle the old problem of "I will know it when I see it," associated with defining project deliverables. You tailor the traditional approach to project management with an approach that meets the agile needs of the project. Agile project management, by its nature, supports direct customer inclusion, adjustments, and even redirection utilizing a type of iterative approach that deals with the level of uncertainty encountered. Through the application of the concepts of quick iterations through a project's activities, developing usable product along the way, to the project team can address uncertainties in scope, business, and the economy. Agile project management, based on the 6 principles shown in the Exhibit 1, still relies on the same A Guide to the Project Management Body of Knowledge, PMBOK Guide, 3rd edition, Processes and Disciplines. just implemented with different practices and tools that supplement the TPM approaches the organization already uses. Exhibit 1. 6 Principles for Agile Project Management. Agile Product Development. Agile project management focuses on the overall management of the project. Agile product development, on the other hand, focuses on engineering activities associated with the project's product, be it a software product or a new pharmaceutical or automotive product. Agility is equally important in these activities, since without a sense of fast movement when developing the product, the project would be bogged down. Some of the methods used include extreme programming, test-driven development, and just-in-time manufacturing, to name a few. The project manager and the project teams must realize that these product development approaches supplement agile project management approaches. The project management approach and the product development approach should be integrated when the team develops their overall project life cycle model. Agile project management for all projects? Many organizations are experimenting with or implementing agile development approaches within software development projects to expedite and increase IT's throughput. While this is encouraging and might help IT with resource allocations, it is not sufficient to address business needs. Many of today's projects extend beyond the boundaries of software development. If the entire project is not accomplished with agility and nimbleness, the benefits gained in software development efforts might be lost. Overall performance measurement is something else to consider when contemplating agile project management for the organization. If performance measurements indicate that improved market position or improved resource utilization could be gained through agile project management, then adopting agile practices becomes a strategic decision across the enterprise. Adoption challenges. We have become accustomed to using formal predictive approaches to force uncertainty resolution in a project and to prevent changes in the project's scope. With agile project management, change and uncertainty become the norm. The project team needs the ability to adapt to ensure project success. A survey conducted by the Agile Project Leadership Network, Barnett, 2007, asked about the challenges organizations faced when implementing agile software development techniques. The greatest concerns expressed related to implementing agile techniques centered around soft issues related to people and the organization, not to the methodology or the tools. These observations are equally pertinent to organizations adopting agile project management. Those that have become comfortable and accustomed to pre-planned linear approaches to projects tend to resist doing nonlinear or adaptive work. Often this resistance is demonstrated through actions like scapegoating, projection of negative claims on a process, or killing off the leader in the hopes that if only we had the right leader, our problems would be solved. In reality, as project managers, we are not frequently in positions of real authority to drive organizational change. We are, nonetheless, in a strategically challenging and personally risky position relative to communicating new approaches that will require a change in thinking, attitude, and perceptions to project team members and sponsors. The following are some suggestions as to how project managers and PMO staff can help with the adoption of these new approaches. PMO as process cheerleader. PMOs generally take a leadership role in helping organizations determine when new and better techniques in the application of project management should be adopted or adapted into practice. Decisions about when and how agile project management techniques are incorporated into the organization's project management bag of tricks are in the PMO's bailiwick. There are situations where traditional project management techniques are best suited for delivery and situations where agile techniques are warranted. The PMO should guide project managers and sponsors as they determine when to use a certain methodology for delivery, establishing boundaries and a structure for all projects, no matter what the delivery process. The PMO should work with project managers and project teams to determine how to best adapt existing processes to be more agile, more nimble, and in the education and communication of these adaptations to the rest of the organization. Additionally, the PMO should serve as the leader in measuring the impact Agile techniques have on the business's overall performance. Project management processes that we see most often impacted by Agile techniques are those associated with project initiation and planning and project controls. It is here that we recommend the PMO spend time providing tools and assistance. Project request. Estimation for budget purpose. One method used on Agile projects is to box in exploration activities and estimate non-exploratory activities as you normally would. Establish a finite budget and schedule for exploratory activities based on past experiences and knowledge. Inform all engaged in the funding decision that there is a high degree of risk in the budget number associated with the project, because exploration is required before you can estimate the remaining aspects of the project. When the original budget is consumed, you will determine overall progress and engage the team and project sponsor in determining how to proceed. If more exploration is warranted, seek additional funding or adjust the estimates associated with the rest of the project based on the knowledge gained through the exploration. If it is not possible to obtain additional funds or delivery date relief, use the knowledge from the exploration to adjust the scope of the final product again. In collaboration with the project sponsor and using a trade-off matrix similar to that shown in the project data sheet depicted in Exhibit 2 to guide the decisions. This approach is similar to the spiral model of software engineering in that there is acknowledgement of uncertainty in the early iterations of the project. Exhibit 2. Project data sheet including trade-off matrix. This time box method can be effective in organizations where budgeting and resource allocation are performed as part of an overall annual portfolio management process. If you are in an organization not constrained by annual planning and budgets are a bit more fluid, then you might consider rolling wave planning, where the estimates are provided only for the next iteration through the project. At the end of each cycle, there is a determination, made in collaboration with the project team and project sponsor, if the next cycle is viable, and to request funding and resources and develop the detailed schedule and budget at that time. Both of these approaches are not for the timid or inexperienced project team. The team needs to be able to draw on past experience to speak with confidence about what is needed to adequately explore a new technology or a new product approach. They then need to be able to visualize how the end products could be delivered in smaller pieces, with each piece building on a prior one. Identifying project end date. Determining the project end date in projects managed with Agile techniques is really no different than the methods used in determining end dates in projects managed traditionally. However, in Agile projects, there is a clear understanding at the beginning that the project plan, including the schedule, will indeed change as iterations are completed. The project plan at the beginning is only a plan, not a finite prescription of how the project will unfold. One key concept that project sponsors need to hear is that project plan changes do not mean the planned final project end date will necessarily change. For one project, the end date may be more important than the final group of features, or it may be determined that the budget will be exceeded but achieve all features by adding resources. A discussion on these constraints is held during project initiation, when determining if Agile project management is the right set of techniques to use on the project. They should then be reaffirmed during the project charter development, and then at the chartering of each of the iterations, acknowledging the constraints might change during the project's life cycle. Estimating time in an Agile project is based on two concepts that are explored by Mike Cohn, 2006 velocity, and ideal time versus elapsed time. Velocity is the rate at which a project team completes development of some number of product features. Ideal time is defined as the time it takes to accomplish a task when all peripheral tasks are stripped away, that is, when all waste is removed from the essential task. Elapsed time, on the other hand, is the clock time it actually takes to accomplish a task. When estimating the schedule for an Agile project, The project team should be encouraged to think in terms of ideal time, since all non-essential tasks will be factored into the project team's velocity. In other words, estimate the effort, not the duration. This is an aspect of schedule estimating that will be foreign to some team members and is worth some concentrated training and awareness. In an Agile project, the project manager and team are continuously planning the next set of activities, the next iteration of the project. There should be a high degree of certainty in the schedule for this next iteration, with decreasing certainty in future iterations. This concept of deliberate schedule uncertainty is one of the largest challenges a project manager will face when adopting Agile project management in an organization where the culture is more comfortable with and policies and processes are aligned with. Traditional project management. Stakeholder management. Education regarding Agile techniques. During the project's initiation phase, the project manager and PMO needs to educate the project stakeholders on what it means to be managing a project with Agile project management techniques. All stakeholders, not just the primary project team, need to be educated as to what Agile project management is and is not and what is expected of their respective roles. There is a new vocabulary, sprints, velocity, stand-ups, etc., a difference in how status is reported, daily status meetings, and multiple releases of functioning products, software or physical. Sponsor. Status will be made available to them at a certain location, portal, and in different formats than before. The traditional weekly status report is not effective or efficient with Agile projects. Project team. Agile product development is known for quick periods of development, unburdened by all, but the most necessary documentation. This calls for a disciplined process with strict time boxing and mandatory daily meetings. Users. Bits of functioning product will be available to validate and use while further product advancement continues, instead of one big acceptance period at the end. Agile project management emphasizes quick iterations through a project. So, there needs to be the realization that while high-level feature requirements with a rough order of magnitude for major deliverables may be able to be defined, by no means will all of the project requirements be visible and able to be defined at project initiation. Therefore, in preparation for the volatility that will come, the focus of initiation in an Agile project is less on the what than it is on the organizational aspects, which will be directing and supporting the project. Obtaining buy-in and participation. Before embarking on the application of Agile project management methods, the project manager overseeing such an effort should understand the risk profile of the organization. Organizations that will readily embrace agility welcome change as a means of opportunity. They are not threatened by change. Organizations that tend to be risk-averse, that have a high need for centralized control and decision-making, and where management traditionally determines progress based on completion of documents and deliverables, will be harder environments in which to introduce Agile practices because the concepts of Agile project management do not align with the principles of the business. A risk-averse organization will place a preponderance of importance on time and status reporting, an attribute of a false sense of control. There will be well-defined processes associated with procurement activities, and acquisitions will require multiple levels of signature. In such an environment, the project manager should clearly communicate the benefits of agility in terms the company will accept and openly address any risks that might be seen. The project manager should plan on an extended period of communications, awareness, and education, highlighting how Agile project management techniques supplement traditional project management techniques. The project team will need to have a plan that embraces the supporting business functions, that brings these functions into the Agile team so that they understand, 1, how they can contribute to agility, and 2, why agility is not a threat to the controls they have in place to protect the organization. After the stakeholders have had some education in Agile project management and understand why it is being applied, The project manager must clearly engage the stakeholders in a cost/benefit analysis to ensure they fully understand why Agile project management is of benefit to the project. By taking the time to do this analysis, the project manager will start the process of obtaining the necessary buy-in and active stakeholder participation. More change in how we manage projects. One methodology, different adaptations. Avoid the tendency to develop a new methodology whenever a new approach to a business discipline arises. Instead, practice tailoring the existing project management methodology. Agile project management can be accomplished with a few adaptations of existing processes, such as daily stand-up status meetings supplemented with a monthly formal report in lieu of formal weekly reports. Another adaptation is the use of some visual planning tools to permit the project team real-time access to update documents, such as risk registers. The PMO should take a lead in determining where these adaptations are viable and in exploring how to best implement them. Determining when to use Agile method. Agile project management is not suitable for all projects. Agile project management reflects just enough project management discipline to ensure the project will achieve its stated goals with minimal risks. Projects that are being executed in dynamic environments, rapidly changing marketplace, fuzzy concept of product features, unstable internal organization, are perhaps better suited for Agile project management because the benefits associated with nimbleness would outweigh the associated project risks. The decision to apply Agile project management methods is not one that the project manager or project sponsor should make in a vacuum. It is a collaborative decision for which all must assume responsibility for the outcome. The associated benefits and risks need to be clearly understood by all project stakeholders, and organizational management needs to be supportive of the decision. We have developed the Agile Project Management Questionnaire, Exhibit 3, as a tool to assist in this discussion, encouraging dialogue regarding the project's constraints, risk factors, and need for speed. Exhibit 3, Agile Project Management Questionnaire. Ready to be agile? Today's global business environment requires businesses to be agile. Ultimately, the decision to embrace Agile project management will be made by our competitors if we do not make it ourselves. Let us ensure we are prepared by having the ability to envision how project deliverables might be developed in usable components, in increments over short periods of time. We need to be able to plan and execute projects with flexibility and decisiveness and react quickly. We need to be able to conduct periodic checkpoints and be prepared to not continue a project, perhaps because the market is not responding to the initial product, knowing the organization has the benefit of some completed product, not just a stack of documentation. More than ever, our businesses demand we be nimble, adaptive, creative, and yet in control of the projects entrusted to us. Are we ready? Are our teams ready? In this topic area, we have learned about the Agile project management methodology and identified many of its advantages. We have examined different project types, as well as business environments, to better understand when this methodology is most appropriate. We have also considered when a hybrid approach using both the Agile and waterfall methodologies may lead to optimal project efficiency and successful completion. Chapter 1 Hybrid Projects. The need to be open to different project management methodologies introduction. I think as project managers, PMs, we often get too wedded to one particular methodology. And we think that this one methodology has to be used in all situations. We become purists for this one approach. Perhaps the methodology is Scrum or Extreme Programming, XP, and we think that this is the modern solution for all projects and can and should be used on all projects. We think waterfall and traditional approaches are a thing of the past and only something our fathers once had to use. There are much better ways to do things today. One, perhaps it's the other way around. Maybe there's a particular methodology or set of processes that our Program Management Office, PMO, insists must be used on all projects. For example, The PMO stipulates that for all projects, there must be a formally approved project charter that is issued by the sponsor before any work is started. Additionally, this reminds me of my time as an HP systems engineer in the 1980s. I was a die-hard defender of HP 3000S and the MP operating system. And I couldn't see my way to say anything positive about the DCVX architecture or the IBM 36370 architecture. Similarly, I'm a die-hard sports fan today and a complete supporter of the Washington Nationals and Washington Capitals. I have a hard time thinking of good things to say about opposing teams. I should really learn to be more open-minded, yes? Must be a written, formally approved project management plan with a minimum of 18 component pieces, including formally approved baselines. The scope baseline must include the scope statement, a WBS, work breakdown structure, and WBS dictionary. There must be management plans that define how work and processes will be done in all 9 knowledge areas except integration management. This formal project management plan must be approved before the execution phases of the project are started. Therefore, we will do predictive planning and move through the phases of the project in a waterfall fashion. Furthermore, earned value management (EVM) must always be used to measure our project's progress against the baselines. This is our culture, and the PMO requires that this approach and set of processes be followed on all projects. But this is too limiting and too narrow-minded, is it not? We need to be more versatile and more open-minded. We need to recognize that no one methodology or process is perfect for all situations. Isn't it also the case that most of our projects are probably large enough and complex enough that parts of the project are very suitable for the tried and true traditional methods or waterfall methods, and other parts require creativity and exploring requirements, so they are much more suitable to Agile? On a large, complex project, isn't it likely that some parts are cookie-cutter, so to speak? These parts involve work packages or items that we've done many times in the past, and we have very good historical records for these parts or work packages. For these parts, we know in detail starting out exactly what the requirements are and what the relative priorities are of the requirements. The customer knows exactly what they want at the beginning. These historical records will allow us to obtain very good estimates of time and cost, and very good templates of different types of key documents that can be used in our project. Therefore, for these parts of the project, it will probably make sense to use predictive planning or a waterfall approach, and also have a fully accountable PM2, who too many people in the Agile community refer to this type of traditional PM who is fully accountable for the project, and who is the single focal point for the project as a command and control PM. Obviously, that has negative connotations and makes it sound if all such traditional PMs are micromanagers and are quite dictatorial. Of course, that doesn't have to be the case at all. Is assigning all the work to the different team members. Perhaps many of these parts of the project will be subcontracted out to external vendors, and the work will be performed under a fixed price contract. We must have all the I's dotted and the T's crossed. There is an extensive statement of work, SOW, and again, it will make most sense to use the traditional approach. For these cookie-cutter projects or cookie-cutter parts of projects, why does it make a lot of sense to use predictive planning, a waterfall approach, and have the traditional, fully accountable PM? Because it is much less expensive and far more efficient to do so. Use the KISS principle, keep it simple stupid, or Occam's razor, don't multiply entities beyond necessity. With Agile, we want to have a team made up of 5 to 10 senior, dedicated members. That's going to be very expensive in most cases. Furthermore, ideally, we want them to be co-locate. That's also going to be very tough to do in many cases today in our modern project world, and also very expensive. In the situation where we know exactly what is needed starting out in the project, this is not necessary. We can go with the traditional predictive planning model, which is much leaner and more efficient, and accomplish our goals in the same amount of time and for far less money. Many of the projects I've worked on in my career at Hewlett-Packard were of this nature. These were logistics projects, data center relocations, or large rollouts, as we called them. We were refreshing the client PCs and other supporting servers for a large customer at numerous office sites. We had done these types of projects many times before, and we had very good historical records that gave us excellent estimates of time and cost. So it did make sense to have a traditional PM. Who was totally 3? Does that mean that these types of projects were simpler and easier? Not at all. Everything in the project needed to run like clockwork, and the customer was often very demanding. There was no room for errors or mistakes. As always, there was tremendous pressure to communicate very well concerning project commitments, communicate completely and accurately to the customer and to other key stakeholders. For this type of project, the old saying especially applies: the devil is in the details. We had to be sure we were on the same page with the customer and the other stakeholders. Accountable for the project, doing predictive planning, and handing out all the parts of the plans of the project to the different team members and subcontractors. These team members were working part-time on the project and were multitasking between a number of projects. Also, the resources on my projects were often spread out over a large geography, so it would be impractical to have them co-locate. That would also increase the cost, and in most cases would not be something that management was readily agreeable to. Again, in my project world, we were using virtual teams spread out over a large geography in almost all cases, and the team members and subcontractors were working on multiple projects at the same time. The landscape for projects today, however, I think the types of projects most of us are dealing with today are much different than what I just described. How would you describe our world today for project management? What good adjectives or descriptive phrases would you use to describe this world that we find ourselves in? I think it's a more difficult, more challenging world today than it was for PMs just a couple of decades ago. The pace of change has increased in amazing ways. Some catchphrases that seem to apply to our world today are make dust or eat dust. If you are standing still, you are falling behind. The only constant is change. This is from 500 BC, ancient Greek philosophy, Heraclitus. Companies are dealing with global marketplaces and more competition than ever. Customers are very demanding, very fickle. The need to adapt to changing marketplace conditions is greater than ever. Change or die. We are dealing with a much tougher competitive landscape today. We will say more about that momentarily, but change is occurring much more quickly than it ever did before. Our customers are more demanding than ever. They're more fickle, and therefore, it's tougher for companies today. They have to constantly find new products, new services, and new solutions that respond to the new demands of their customers. They must adapt to the changing landscape of what customers are looking for. I think Jeff Sutherland sums it up best in his book, Scrum, The Art of Doing Twice the Work in Half the Time. He simply says, change or die. Think Thomas Friedman, in several of his more recent books, explains well how and why we have reached this new age, an age of tremendous change and increased competition. He terms this new age an age of accelerations. He has written 3 books that all address this topic. The first book was The World is Flat. The second book, That Used to Be Us, How America Fell Behind in the World It Invented. A fairly scary and eye-opening book for those of us who live in the United States. And the third book, Thank You for Being Late. Each book builds on the themes and key points made in the preceding books. Friedman points out there were 2 things that happened together over 2 decades ago in the early 1990s. First, it was the breakup of the Soviet Union in the late 1980s that ushered in a new era of globalization in the early 1990s. That brought new countries into our capitalist marketplaces, and this raised the bar of competition in very significant ways. Of course, we're talking about China, but also India and many other countries. Something else also happened at the same time in the early 1990s that was a tremendous game changer. Of course, that was the advent of the internet, and the internet has changed almost everything about how we live, how we play, and how we do business and work. Global teams can collaborate on work, share documents, and communicate in very creative and new ways. Here is another type of example of how the internet has changed our world. Imagine that a group of young entrepreneurs has come together with an idea for a new business solution. The team is confident this business solution is going to have a lot of appeal to people and make a big impact. They don't need the old-fashioned brick-and-mortar manufacturing operation to produce the products they are envisioning. They can outsource that. For advertising and marketing, they can outsource that too. They can even find very creative ways to get financing to provide the necessary funding for this opportunity. Bottom line, it's much easier today for people to form new companies to go after opportunities, and people are doing exactly that today. This has raised the level of competition in major ways. A number of different writers say that the internet has brought about as profound a change in our world as the Gutenberg printing press did in the 15th century. So, in short, we're living in this age of accelerations with tremendous change and a heightened level of competition. Why does this matter to us as PMs? Why do we care about all this volatility, difficult marketplaces, and the challenges our companies are facing? Of course, it's simply because we are helping our companies survive in these difficult times. We are managing change for them, and we are helping our companies create the new products and solutions that will resonate with customers. We are drivers of change in this new world. Therefore, our companies need us to be very good at managing projects and to be up to speed with the latest methodologies. So, what project management methodology is best suited for coping with change and handling volatility? Of course, that's an easy answer. The answer is Agile. But we shouldn't discard the tried and true, the traditional waterfall approaches. As we'll see, this methodology also has an important role in many projects. We need to be open-minded and know when and where to use the different approaches and the strengths and weaknesses of the different approaches. The roots of modern project management and the case for traditional project management. From what industry did project management arise, and who wrote the first books and anthologies on project management? It was the construction and engineering industry that provided the foundations of our modern project management practices. The first authors of college textbooks on project management were engineering professors, people like Cleland and King, 1968, and Harold Kersner, 1979. Some people might say that modern project management starts with Henry Gantt and Gantt charts in 1910. These were used successfully with the Hoover Dam project in the 1930s. Other people point to the 1950s with the advent of program evaluation and review technique, PERT, which was used with the Navy Polaris submarine program, and with critical path method, CPM, devised in the late 1950s at DuPont. Also, much of the traditional project management approach comes to us from the 1960s and the Department of Defense, DoD. Much of what we teach in our project management professional, PMP, prep classes is based on the core principles developed in DoD, especially EVM and the WBS. The WBS is a key part of Earned Value EV and is very close to the heart of the traditional PM. The WBS drives all planning, or is the cornerstone of all planning. It drives scheduling, cost estimating, and budgeting, determining quality acceptance values, resource estimating, identifying risks, and deciding what we want to outsource. Of course, we also have the 100% rule. 100% of the project must be in the WBS. If it's not in the WBS, it's not in the project. What is the life cycle model that is very closely tied to traditional project management? The waterfall life cycle approach and the use of predictive planning. This model entails performing exhaustive, detailed planning for all phases of the project at the beginning. The devil is in the details. Therefore, don't leave any stones unturned. Figure out all requirements in detail in your planning phases at the beginning of the project. Plan everything so well from the beginning that change won't be needed. As Harold Kersner says in his textbook on project management, do planning so well that scope changes are kept to a minimum. Hierarchically decomposing your original business requirements and functional requirements to a very detailed level using a WBS. Obtaining accurate, detailed estimates for time and cost at the work package level using techniques such as bottom-up estimating, parametric estimating, and per three-point estimating. Measuring performance during the project using EVM. Measuring performance against all three baselines, scope, schedule, and cost, using EVM and using quantitative risk analysis techniques to more accurately define contingency reserves to include in the cost baseline and schedule baseline. If you're building a new bridge or building, you probably want to use this waterfall approach. You had better get very detailed, accurate blueprints created before you start construction. Then, you will need very accurate baselines with which to measure your performance. Detailed blueprints and a WBS will allow you to create an accurate schedule and budget so you can measure your performance against time and cost. Ideally, you will use EVM to do this. In EVM, they like to say, to do project management properly, you need to have defined scope. If you have this, you can define all three key baselines, scope, schedule, and cost. EVM really works hand in hand with traditional project management and a waterfall approach. For EVM to work, we need to have very accurate baselines and a very accurate BAC, budget at completion. In an excellent book on EV written by Fleming and Koppelman, Simple Earned Value on All Projects, simplified translations of the 27 EVM criteria, they state the most important of all the 27 criteria is the very first one. Here is their translation. Step 1. To the extent possible, you must define the full scope of the project. Equates to EVM criterion number 1. This is perhaps the most important requirement for implementing earned value, and perhaps the most difficult to achieve. Management of certain types of projects, notably software, often give up at this point and refuse to go further. They often relinquish, page 160. They go further on page 178. The first group of criteria deals with the requirement for any new project to be completely defined and planned prior to starting performance of the work. Today, we would typically call this effort defining the scope of the project. Think about it. Earned value measurement cannot take place without some definition of what constitutes 100% of the project. Why is it so crucial in construction and engineering to first obtain the full scope of the entire project, all the requirements spelled out in detail, before we start construction? The answer is pretty obvious. If there's a mistake in our blueprints and construction begins, and if the mistake in the blueprints is not discovered until weeks have gone by and a lot of construction work has been done, all that engineering and construction work might have to be torn up and redone. Of course, that is going to be very, very expensive. Someone's probably going to lose their job. My youngest son, Michael, works for a design/build mechanical firm using 3D CAD, computer-aided design. He's creating the blueprints for all the mechanical and plumbing work in large high-rise apartment buildings. He's told me, Dad, if my blueprints for the mechanical and plumbing design in the building are off by even a quarter of an inch, then there will be hell to pay. Predictive planning must be done, and every detail nailed down too. Michael's BM, Building Information Modeling, team must coordinate everything at the start of a construction project to collaborate with the engineering team and make sure each floor of the building is clash-free virtually before construction starts. This is necessary to avoid expensive change orders that could potentially happen in the field. For example, suppose the BM team didn't realize there was a 24 by 48 beam blocking a 22 by 14 duct going into the lobby area. The devil is in the details. Is predictive planning and this attention to detail only critical in construction and engineering projects where the cost of change once we started construction could be very, very high? If we're doing a software application and the change will just involve moving bits around and recompiling programs, do we still have the same urgency to get all our requirements totally correct at the beginning? Is it even possible to do that? On construction projects, it's usually the case that the customer knows much more precisely what they want going into the project than they would on a typical software project or knowledge work project. Perhaps it is a new office building. In most cases, the customer will know exactly what they can afford when the building needs to be completed and the other requirements, number of offices, conference rooms, size of the lobby area, number of floors and footprint, power and HVAC requirements, networking requirements, architectural style, and so on. The architect will create detailed blueprints and models that the customer will review and accept before construction begins. Or perhaps it's a home kitchen remodeling project. The key stakeholder, the wife, will choose exactly what appliances she wants, the cabinets, and countertops. Perhaps a general contractor will be engaged, and after design meetings with the homeowners, they will create blueprints or CD drawings of the new kitchen that the homeowners will accept or modify. Again, the customer will determine, in detail, all the requirements before the demolition and remodeling phases begin. Therefore, on these types of projects, it's a much more straightforward process to obtain all the requirements up front at the beginning of the project. These types of projects are much more conducive to using a fixed-price contract. Once given the detailed requirements, the contractor will be able to determine their costs precisely and generate a fixed-price bid. Fixed-price contracts and other contracts are presented in more detail in Chapter 2, Agile Contracts. Can Agile be used with fixed-price contracts? Risk number 1, the number one risk on projects. There are several other reasons the traditional waterfall methodology often makes sense. What is the principal cause of failure on projects and, therefore, our number one risk? It's having a poorly written scope statement, a vague, ambiguous scope statement. If we allow that to happen, there will be no hope for this project. In a key process, validate scope, defined in the Scope Management KA, Project Management Body of Knowledge, PMBOK Guide. 5. We bring in the customer to inspect deliverables that we've created and obtain their formal acceptance. If our scope statement is vague or ambiguous and the acceptance criteria in the scope statement are poorly written, not smart, aspecific, immeasurable, agreed, are illistic, and time-bound, how is this meeting with the customer going to go? Of course, not well at all. What are we likely to hear? I'm sorry, but this isn't exactly what I'm looking for, and of course. Weren't you listening? I absolutely need to have these other requirements too, etc. And if our scope statement is vague or ambiguous, and if the acceptance criteria for this deliverable were poorly written, then we're going to have to add in these extra requirements at our own expense. This leads to what we hate most, scope creep. 6. Scope creep is the uncontrolled expansion of project scope or product scope without making adjustments to time, cost, and resources. 7. Which leads to schedule delays, budget overruns, customer satisfaction issues, and senior management satisfaction issues with the project. And, very likely, a new PM. Therefore, follow all the PMBOK guide planning processes in scope management very well. Plan scope management, collect requirements, define scope, create WBS. Following these processes ensures you are on the same page with the customer, all the requirements have been captured, and the acceptance criteria for the deliverables are smart. This leads us to a discussion of why the job of the PM is a very difficult job. I like to say, project management is not for sissies. Project management is essentially all about people skills or soft skills. It is not really about understanding the technical intricacies of scheduling tools like Microsoft Project, Primavera, or Artemis, e.g., understanding how to do a forward pass and backward pass, understanding the difference between total float and free float. It is not about understanding the arcane tools and techniques mentioned for quantitative risk analysis, EMV, expected monetary value, or Monte Carlo simulation, or decision trees, or a sensitivity analysis. It is not about the IQ, intellectual quotient, part of the equation. It is about the EQ, emotional quotient, part of the equation, or emotional intelligence. What is the key part of emotional intelligence, or the key part of people skills and soft skills? Clearly, the answer is good communication skills. What is the essence of having good communication skills? Something that technical people like me have a lot of difficulty with. Good listening skills. All good communicators are necessarily very good listeners. In the PMBOK guide, PMI does not put any priorities on the processes in the different knowledge areas. But I will go out on a limb and do that. I think the highest priority knowledge areas are scope management, communications management, and stakeholder management. Success on our projects directly depends on how well we perform key processes in these knowledge areas, and these knowledge areas all really overlap one another. Figure 1.1. Requirements. Charter-Scope Statement Communications Stakeholder Management Figure 1.1 Foundational Case Processes 1. As we said, our principal risk involves doing scope management well, and this starts with doing the requirements gathering process well. Don't miss any requirements. Don't misunderstand the requirements. 2. Don't misunderstand the complexity of the requirements. Decompose requirements properly. Don't miss any key stakeholders in obtaining requirements. Successfully obtaining requirements involves communicating very well with the customer and other key stakeholders. This includes listening. Follow well-accepted practices like JD, Joint Application Design, and QFD, Quality Function Deployment. In essence, get those engineers out of their offices to go meet with the customer. Have productive conversations with the customer to truly understand what they are seeking. Don't assume that we know best what the customer really wants. Get out of our offices, follow the customer around to see what they're really needing. Even better, try out their job for part of the day, so we truly understand what they need. Let's assume that we do the requirements gathering process very well. We erred on the side of inclusiveness. We've done brainstorming, we've been creative, and we correctly captured all the different stakeholder requirements. Are we now in good shape? Are we going to be successful? No, not necessarily. This is where the hard part of project management comes in. Are the stakeholders all in agreement for the requirements for the project? Of course not. The requirements they want are all over the map. They have different needs and different wants. Somehow, someway, we have to get them onto the same page. If we don't do that, this project is surely going to fail, and who's going to take the blame? Not these stakeholders who are giving us all these inconsistent requirements. No, you will take the blame, the PM. Many of the PMP prep books completely misunderstand this key point about what is happening as we move from collect requirements to define scope. The PMBOK guide doesn't even emphasize this enough. Many people think that as we move into define scope, we are just digging into more and more detail. That is not the key purpose of define scope. No, the key purpose is to get everyone onto the same page, define boundaries, and define exclusions. This is the hard part of project management. No matter what powers we have as PMs, we could be that very empowered PM in a strong matrix organization that we assume is the default for the PMP3. Exam. We will never have enough power to legislate what will be in scope and what will not be in scope. No matter how powerful we are dealing with stakeholders who are much more powerful than we are, the sponsor and other senior managers in our own organization, the customer, even stakeholders in other organizations, e.g., federal regulatory organizations. Nonetheless, for this project to succeed, we must get everybody onto the same page. We must define the boundaries and the exclusions for the project. If this doesn't happen, this project will fail. I've been to many dinner meetings for the Washington, D.C. PMI chapter, PMIWC, over the past 20-plus years, and I've heard many excellent presentations about projects where things went dreadfully wrong. In almost all cases, F-22, Affordable Healthcare Act website project, etc., these projects failed because this problem was not correctly handled. So, we must obtain requirements correctly and create a well-written scope statement with smart acceptance criteria. To do that, we must do communications very well, but we must also do stakeholder management very well to define these boundaries and exclusions. By the way, who is most of the risk in this situation? The sponsor? The customer? The senior managers who gave us the incompatible requirements? No, the PM has the risk. If we fail to get everyone on the same page and proceed trying to run this project, it is surely going to fail. When that happens, who will take the blame and who will be looking for a new job? We will, the PM. Criterion number 1, defined in the most current EVM specification, is directly addressing this point. To the extent possible, you must define the full scope of the project. 4. But let's suppose we do all this correctly. We do correctly follow the planning processes in scope management defined in the PMBOK guide. We do get boundaries and exclusions defined, and do get everyone onto the same page. Does that now guarantee success for the project? No, it does not. The case for Agile, suppose the customer doesn't know exactly what they want at the beginning of the project, and they want a new solution created for them. They know high-level business requirements or functional requirements, but they don't know the exact detailed engineering solution. That needs to be explored and discovered, and it's understood there's going to be some trial and error in discovering the best engineering solution. But instead of using an iterative approach, we follow the guidance of Fleming and Koppelman, and we do our best at the beginning of the project to uncover in a detailed way all the scope requirements. It is 1978, and we are using a waterfall approach for developing this application. We are going to do predictive planning. Waterfall approaches using predictive planning were typically used for developing software applications in the 1970s and 1980s. Some people are still using this type of approach for software applications today. A simplified view of the waterfall lifecycle model we used might look like the one in Figure 1.2. We spent several months interviewing all the different stakeholders on the project, making sure that we didn't miss anyone or leave anyone out. We thoroughly captured all of their requirements for this new application, layouts of reports they wanted to see, the graphical user interface, GUI, for input screens, file layouts of other input files, expected response times and throughput times, and other details. We created the user requirements documentation, the functional specification. We obtained all the necessary approvals and had a bow tied around these documents. We then turned over these documents to the systems analysts, who did the detailed design. They hierarchically decomposed the application, from the application down to programs, from the programs down to modules, from modules down to subroutines, and from subroutines down to functions, and so forth. They defined the interfaces between each level and the parameters that would be passed. They defined all the file layouts. This also took several months to accomplish. Again, the necessary approvals were obtained on the subsystem specification or the system architecture document. Now, the system architecture documentation was turned over to the COBOL and Fortran programmers, who did the coding and development. How long did that take? An average application at the time of 1978 was usually more than 100,000 lines of code, and it typically took more than a year to do all the coding and unit testing. Then the programmers brought all their code together to do integrated testing, and this could also take more than a month or two. Finally, that glorious day arrived, UT, user acceptance testing. How did UT go? Not well at all. Why? Well, how long was it before the customer really got to see the running application? It was 18 months or longer. What's happened in that year and a half? The world has changed. By the time of UT, there were much better ways to do things. Better ways to index records to provide faster response times, and better GUIs and screen designs for inputting data and reviewing data. The customer wanted these new technologies and was not happy with an application that had been designed 18 months or more earlier. Even more fundamentally, it's not until the customer uses the application, sees real response times and throughput times, plays with the screens and sees how everything works that they realize what they really needed in the first place. So, they are not happy at all. Therefore, Fleming and Koppelman were wrong. It's not that as software PMs we gave up too soon and didn't try hard enough to determine the real requirements the customer needed. It just wasn't possible to do that. The world was changing too quickly, and at the time of obtaining the user requirements, we could not see, and the customer could not see, how things would change and what detailed engineering solution would work best. In our world today, Tom Friedman's Age of Accelerations, as PMs, we are dealing much more with the cone of uncertainty, figure 1.3. In the first iterations of the project, it's impossible to predict accurately exactly what detailed design solution will work best for the project at its end date, perhaps 1 year out or longer. The world is changing very quickly, and new technologies and solutions will become available, and these will likely change the final engineering solution the team decides upon. It's also impossible at the beginning to get accurate forecasts of time and cost for the entire project or release. Our job is to discover and explore what will work best. It's implied that in this age of accelerations and very volatile requirements, we are under much more pressure to deliver quickly, and there are tight schedule constraints. We need the team of 5 to 10 senior, collocate, generalizing specialists to help us meet these tight schedule constraints. So, what is the best way to handle these types of situations? For software applications or knowledge work, projects based on intellectual work and design work, the best approach is to do things iteratively, use Agile. In very short iterations, 1 to 4 weeks, get a subset of the application out to the customer, and let them kick the tires, so to speak, and find out what has value and what does not. The Agile lifecycle is going to look as given in Figure 1.4. Once we get through the initiation phase and the release planning phase and into the development iterations, each development iteration is a vertical slice of the entire project, and aspects of all phases are used in each development iteration. Also, it goes without saying that all 5 process groups are used in each iteration. In each development iteration, we will do planning. We will execute against those plans to create product increment, something empirical and tangible, usually a prototype of some deliverable, but not a throwaway prototype, and something that can go into production. In each development iteration, we will also do testing and quality control, QC, and get acceptance from the product owner and/or customer. A key aspect of what happens using Agile approaches and doing things iteratively is that we are using Lean. Lean is a core part of all the different Agile methodologies. With Lean, we are grooming the value chain and identifying fast failures or identifying failures fast. When we go to obtain requirements from our customers, what are they likely to give us? Everything. Really. Everything under the sun remotely imagined for this project. And everything is priority 1. Doesn't the federal government do this in most of their requests for proposals, RFPs? As I remember things, for a large federal IT procurement RFP in the 1990s, TC4, there was so much in the RFP that even a huge company like mine, Hewlett-Packard, could not meet all the requirements on our own. We had to find vendors and subcontractors who could fill the gaps of what we could not provide to have any hope of winning this opportunity. Was the federal government likely to use all these requirements? Never. In one Standish survey of several years ago, It was quoted that 65% of the requirements the customer thinks they absolutely have to have will never be used. There is some controversy about how the Standish Group came up with this 65% number, but another way of viewing the situation that is widely accepted is another version of Pareto's Law. For quality management, all my PMP prep students know that Pareto's Law is 80% of the problems come from 20% of the causes. In sales, Pareto's Law is 80% of your orders come from 20% of your customers. In requirements, Pareto's Law is 80% of the customer's need comes from 20% of the requirements. Therefore, using Agile, we will go after this 20% of the requirements in our first iterations. Very quickly, we will get something out to the customer that is empirical and tangible and demonstrates this product increment to them. We will find out what has value and what does not. If features we've included in the product turn out not to have value, then we will delete these from the backlog. We won't invest in them further. We won't have to do further integrated testing. We won't have to do as much documentation, and therefore, we will save time and we will save money. We will keep grooming the value chain using Lean. Creating something that's empirical and tangible, and then demonstrating this to the product owner and the customer also has tremendous value. It is far more valuable to show them something empirical than just have them review large documents of specifications. In a wonderful quote from Doug DeCarlo in his excellent book, Extreme Project Management, he says, "If a picture is worth 1,000 words, a prototype is worth 1,000 pictures." The product increment we are creating in each iteration is very similar to a prototype, but it is not just a model or a mock-up of the deliverable that will be thrown away. What we are creating is a subset of the overall application or solution, but it is something that will go into production. In Scrum, The Art of Doing Twice the Work in Half the Time, 8 Sutherland gives us a number of real-world examples of the benefits of Agile. One of these case examples was from 2006 and involved Medco. 9 at that time, Medco was the world's largest online pharmacy. Here are some key bullet points from this case example. Medco, 2006 at the time. Medco was a Fortune 100 firm, world's largest online pharmacy. Medco planned to roll out a new online pharmacy that would link patients with a pharmacist who would review all their different prescriptions and ensure there were no conflicts. Furthermore, they would guarantee a significant cost savings for patients moving to this online pharmacy. The CEO had checked with the IT management team and received assurances this was technically feasible, but he did not get any details on how long it would take. He promised Wall Street that this new online pharmacy capability would be available in 1 year, by July 7, 2007. Wall Street loved this entire idea, and Medco's stock took a very nice jump upwards. However, the people who had to implement this capability did not learn they would be going forward with the massive project until after the CEO had made the commitment to Wall Street. But the challenges to implement this were immense. Much of the software the company relied upon to direct on-site robots was badly outdated. In Medco's 5 gargantuan plants, filled with 4,000 pharmacists processing prescriptions, robots whizzed about pulling pills while other robots handled packaging and mailing, and all those systems had to talk to one another with 100% accuracy, or someone would die. It took the company 6 months to figure out they couldn't do it on time. In the best-case scenario, it would be a year late. They thought they could plan everything ahead of time. They spent months of effort making a detailed project management plan with pretty charts. This was all fiction. There were reams of paper outlining requirements, compliance, all sorts of reports, and quality assurance, QA. The stack of requirements documentation was 2 feet tall. There were so many people involved and at loggerheads that everything was deadlocked. So, they used the Scrum process to pull out the most essential requirements, backlog items. They wrote all these items down on sticky notes, plastering the walls with hundreds and hundreds of sticky notes. This process of pulling out the minimum viable product items and writing them down on sticky notes took several hours. Then, they conducted a high-level estimation of the backlog items. And finally, what do we need to do first? Prioritize the work. What is the 20% of the requirements that would fulfill 80% of the need? Bottom line, Medco met their July 2007 date. I believe many Agilists miss the key point of using Lean. They think the key purpose of using Lean with Agile methodologies is eliminating and reducing waste. Here are the classic 7 key types of waste from Poppendieck that we focus on eliminating. Partially done work, extra processes, extra features, task switching, waiting, motion defects. Eliminating this type of waste is important, but this is not the key thing we are achieving using Lean. As we are seeing in this Medco example, the most important benefit of using Lean for our projects today is identifying the 20% of the requirements that will provide 80% of the customer's need and continuously grooming the value chain. We are going to save time and money if we do this right. Involving the customer on a much more frequent basis to review what the team is creating is also instrumental to achieving this goal. If we use Lean properly, we are going to create something of higher value as we iteratively move through the project than if we used a predictive planning approach to figure out everything in detail at the beginning. Starting out, we can't predict exactly what it is we will achieve at the end of the project or at the end of the release, but if we use Lean properly, it will be of higher value. At a College of Performance Management, CPM, meeting I attended a couple of years ago, this was a meeting attended by more than 50 senior EVM program managers. The attendees were trying to solve the problem of how they could use Agile effectively with their EVM programs. The federal government was demanding that they do this, and frankly, the program managers were scratching their heads and wondering how and why they should do this. They could see the benefits of running daily stand-up meetings in many of their projects and using burn-down charts and Kanban boards, but from my vantage point, they were missing the whole point of why we use Agile. It's really about reaping the benefits of using Lean, especially for software and knowledge work projects. As I'll discuss further, if we do this right, we can achieve a 300% or greater improvement in our productivity. After the meeting, in the social networking part of the meeting, I tried to explain this to one of the EVM program managers, and he looked at me incredulously and said something to the effect that I was an Agile zealot. I'll leave out his exact phrasing. I replied back, no, I'm really not. I'm an enthusiastic hybrid zealot. Again, my exact words will be omitted. 10 in Agile, we're actually improving and speeding up the classic Plan-Do-Check hacked PDCA loop. The PDCA loop was given to us by Walter Shewhart and W. Edwards Deming. Shewhart originated this idea in 1939, and Deming added on more thought for its use in 1950. The PDCA loop has become the foundation for the best accepted practices in quality management for how to achieve continuous improvement, or Kaizen, on our projects. Kaizen is the Japanese term for continuous improvement. Kai is to alter or to change. Zen is to improve. The idea is to make small incremental, continuous improvements in all aspects of your project, your products, your plans and documents, and even your processes. Don't try to solve everything at once. Don't try to boil the ocean. Do things incrementally and iteratively. Of course, this shouldn't only be applied to projects. It applies to both projects and operations. It applies to all steps in the entire product life cycle. In fact, the PDCA loop and Lean and the Toyota production system have their origin in manufacturing processes and operational processes. The best of the modern proprietary quality methodologies, Six Sigma, Toyota production system, Lean, capability maturity model integration, CMMI, just-in-time, JIT, ISO 9000, International Organization of Standardization, are focused on improving operational and manufacturing processes, and using the PDCA loop is emphasized in all these proprietary methodologies. Lean later evolved into the lean software development movement as a subculture of the Agile movement in the early 2000s. But interestingly, in the PMBOK guide for determining the business case for the project and in the cost management chapter, doing lifecycle costing has always been emphasized. Thus, this is a part of traditional project management. The idea is, as you do your project, don't take a short-range view. Don't make decisions that save money and costs for the project lifecycle where such decisions could lower quality on the product or make it hard to maintain the product in operations and, therefore, hurt the company in the long term. Take the long-term view. Design the product for the long run, so it is easy and practical to maintain and has the right level of quality, so it doesn't have to be repaired frequently to protect the company into the future. Therefore, as we do our projects, protect the entire product lifecycle. Design in the right QC processes. Make sure the project is consistent with the company's quality policies and methodologies, and that process improvement processes have been designed into the project. Use the best quality processes inside the project itself. In Agile, we're speeding up this PDCA loop in some very important ways. On a classic software development project, circa 1978, how often did we meet with the customer? Not very often. We met with them at the beginning of the project to obtain user requirements and to write the functional specification, and then we went away for almost 2 years to develop the application. It wasn't until UT, oftentimes 2 years after the start, when the customer saw the real, running application. We might have demonstrated some mock transactions or models of the application at various times to them in the interim, but it wasn't the real application with real response times, throughput times, and actual transactions. So, again, there was usually some real disappointment at UT with the application we had developed. In Agile, we're taking a very different approach. We're speeding up the feedback cycles with the customer in important ways, but also between all members of the project team. Using pair programming, code is tested in seconds. Unit tests/automated testing, there is feedback in minutes. Continuous integration, feedback in hours. Customer collaboration, feedback in hours. Stand-up meeting, feedback once a day. Acceptance test, feedback in days. Iteration demo, review meeting feedback in weeks. Release review meeting, feedback in months. Increasing the frequency of communications with the customer and the feedback loops within the entire team significantly reduces the cost of change on a project. When I am teaching a PMP prep class, I get to a juncture in the class where I ask, when do stakeholders have the most influence on a project? And the students readily reply, they will have the most influence, of course, at the very beginning of the project. And the reason is simple. The cost of change is the lowest at the beginning of the project. Once blueprints have been created for the project, then the stakeholders' influence has decreased, because if they change their mind on the design, they will have to throw out the existing blueprints and get new blueprints created. Of course, that is expensive. Once the actual construction of the building begins and a key stakeholder changes the design for the building, then the cost of change is prohibitively high. Their influence to change the project at that point is very limited. Their influence decreases as the cost of change increases. So, we show the students a slide where we see the cost of change as a line running diagonally to the influence of stakeholders. It would look like that in figure 1.6. However, for a project where we are creating a new software application or for a knowledge work project, the cost of change line is not really a diagonal line. Since there is a lengthy period of time between the requirements gathering process and UT, oftentimes more than a year, the cost of change line will have a nasty curve or uptick at the end of the project. Every change the customer wants at that point will have tremendous ramifications. Every change will touch many other parts of the project and will be very expensive. The cost of change line ends up looking like that in figure 1.7. With Agile approaches, by increasing the frequency of communications with the customer, by increasing the number and frequency of feedback loops and by speeding up the PDCA loop, we flatten out the cost of change curve. Since we are meeting with the customer at minimum every month in iteration review meetings, but in most cases much more frequently than that, the cost of change line looks like as in figure 1.8. Jeff Sutherland gives us a couple of examples of how speeding up the feedback cycle and also the PDCA loop can reduce the cost on a project. These examples are provided in the section entitled Do It Right the First Time and Fix Problems as Soon as You Find Them. 11. The first example involves a lesson learned at Palm in the early 2000s with their production of applications for personal digital assistants, PDAs. These devices were the predecessors of our smartphones today, and originally, they provided a number of applications such as a calendar function, spreadsheet software, and a notebook function. Palm learned that if a bug was discovered in a new application being developed, if the programmer fixed the bug immediately, it took 1 hour to make the fix. If the programmer waited 3 weeks, it took 24 hours to make the fix, or 24 times longer. A second example contrasts the way Toyota produces a Lexus today with the way a Mercedes or BMW is built. A Lexus is made in 16.8 hours with 34 defects per 100 cars. If anyone on the team discovers a defect, they can stop production until the defect is fixed. In contrast, a BMW or Mercedes is made in 57 hours, and the German manufacturers do their quality testing after the car is produced. They spend more time fixing problems than Toyota does in producing their car. Using Agile and Lean can provide tremendous advantages to us and help us avoid some of the classic pitfalls with our number one risk, a poorly written scope statement or not being on the same page with the customer. This is especially important in our modern world of very volatile requirements and tremendous change, Tom Friedman's world of accelerations. Also, providing something empirical and tangible to the product owner and customer on a very frequent basis has tremendous advantages. Again, Doug DeCarlo's quote is especially apt here. If a picture is worth 1,000 words, a prototype is worth 1,000 pictures. Sutherland says that the normal productivity gain from using Scrum will be 300 to 400%. Some teams have achieved an 800% improvement in productivity. He cites another case where a business friend was very impressed with a 25 to 35% improvement that they had achieved using Scrum. His immediate reaction was, "You must be doing something wrong." The key benefit is not providing new tools for the development team. No, the key benefit is much more frequently demonstrating product increment to customers, the product owner, and determining what has value. As we said, Lean is actually something that needs to be used all across the entire product lifecycle, from business development, through the project lifecycle, through testing, through QC and QA, through integrating and cybersecurity, and into the full part of the operational lifecycle. This is a key point the DevOps authors are making. In the DevOps handbook, the authors say that after the manufacturing revolution of the 1980s, driven by lean principles and practices and the Toyota production system, organizations that did not implement lean practices lost market share, and many went out of business entirely. 12. So, Agile and Lean are the solutions to all our problems, yes? Silly rhetorical question, of course. No, there is no one perfect process or solution to solving all our project management problems. There is no one process that's a panacea or which provides an easy way out. We have to be more flexible than that and realize we may have to use multiple processes and approaches. We're going to have to mix and match. More than that, project management is hard work. That is just flat out the case. Getting everyone onto the same page and prioritizing and getting agreement on requirements are hard work. We're negotiating, facilitating, communicating, and using all the soft skill parts of project management to reach that goal. We're often working with very powerful stakeholders who outrank us in our own organization or in outside organizations, and these stakeholders all have different needs, different wants, and different expectations for the project. This isn't going to be easy. There is a lot of pressure to meet very tight schedule constraints and budget constraints and achieve high quality. No pressure. The emphasis is clearly on the EQ part of the equation, not the IQ part of the equation. Agile, by increasing the frequency of communications and by using low-tech and high-touch communications, is helping in key ways. But again, it's not a panacea. In the classic PMI model, defined in the PMBOK guide, the PM is accountable for the project and for making all this happen. In the traditional or classic scenario, management wants that single point of contact for the project or that one throat to choke. In the Agile model, especially with Scrum and XP, the closest role to the PM is the Scrum Master or the coach. In Agile, the Scrum Master is not a large and in-charge PM or a traditional, fully accountable PM. The Scrum Master is a servant leader, and his or her job is to make life easier for the team members. Scrum Masters make sure other team members aren't interrupted and interfered with during the sprint/iteration. So, their job is to carry food and carry water. They are the owners of the methodology and the go-to person when there are questions about how to best use the methodology. However, the team all together, the developers, the Scrum Master, and the product owner, is accountable for the project. How can that possibly work? How can multiple people be accountable? Management is surely going to want that single point of contact. Yes, that one throat to choke. Actually, this can work and does work because of the frequency of communications and the frequent feedback cycles. The idea is that management, and also the product owner, can wait 1 to 4 weeks for the end of the sprint/iteration for the review meeting to inspect the product increment, deliverable that was created in the sprint. Decide if this deliverables meets the definition of done, and decide whether it is acceptable. The entire team is accountable for what has been created in the iteration and what is being demonstrated in the review meeting. Problem areas for Agile is not a perfect solution for all projects. What are some key problem areas and some key types of projects where Agile is not a good fit and why? Here are a few examples to use as a starting point for our next section on how do we make hybrid approaches work. 1. If we do not have the right type of working relationship with our key stakeholders, the sponsor and other senior managers, customer, functional managers, and other stakeholders, then Agile is not going to work as it should. As was said before, it is best to use Agile for projects when the customer doesn't know exactly what they want starting out in the project, and we need to discover and explore requirements. Thus, there is a premium being put on creativity. Therefore, the team needs to be provided a lot of freedom and trust in exploring what the best solution might be. It follows that Agile is not going to be the best fit in the following circumstances. If there is a lack of trust or working experience with all the stakeholders and stakeholder groups. If the customer and management do not accept that we are in a time and materials world where we need to discover and explore requirements, then Agile is not going to be the best fit. Management must understand the benefits of Lean and Agile and must understand they need to be involved in the review meetings and the frequent feedback loops for this to work. If they are insisting on fixed schedule constraints where fixed detailed design objectives must be met, this is not the right fit. Point 13. If management thinks Agile is just a nice set of tools for the developers and programmers that will increase their product 13, the acceptance criteria, or definition of done, will be more high level, as in a dynamic systems development method, DSDM, contract type, then they would be in a fixed price, FFP, contract. They will be about high-level functional requirements, not detailed engineering design requirements. A number of different engineering designs could meet the functional, high-level requirements, and we are entrusting the team to explore and discover the right engineering design. So, management must be accepting of this. There must be more flexibility, trust, and tolerance in assessing what meets the definition of done. But we are more in the world of Ikawisi. I'll know it when I see it. So, management must understand this well. We can't start out the project with preconceived notions and demands for the final detailed engineering design. Also, we can't have the situation where we sell the concept of agile and lean to management. At the outset of the project, they profess to be quite accepting of this approach and say they see the benefits. Then, in the middle of the project, life happens. Some emergency comes up and management quickly reverts back to a classic mindset and insists on fixed constraints for time and cost, but also fixed scope requirements that are detailed engineering requirements. This was not the agreement between management and the team starting out. We must have a strong relationship between management and team and know there won't be such a change in mindset partway into the projectivity and they do not have to get involved. Then this is not going to work. Using Agile will not meet expectations. If management doesn't provide the right culture for the Agile team members, a theory-wide type environment, 14 empowering the team and providing a lot of freedom and trust, then this is not going to work well. Point 15, we will explore this topic in more depth in the section. How do we make hybrid approaches work? 14 Theory X companies and Theory X managers start with the belief that their employees do not enjoy their job and do not enjoy work. If you start with that premise, then you will believe your employees will be lazy, careless, inefficient, and unmotivated. You will have to micromanage them closely to achieve the right business results. Theory Y companies and managers start with the opposite belief. They believe their employees do enjoy work, want to do a good job, and if they are provided freedom and trust, they will achieve the right business results. 15 Many Agilists think they invented this enlightened culture of providing freedom and trust to the team members, the Agile ethos. They did not. I believe this culture really started with Hewlett-Packard in 1939 and was a core part of the HP way. This became the foundation of most companies in Silicon Valley from the mid-1970s through the early 1990s. Walter Isaacson, in his book, The Innovators, How a Group of Hackers, Geniuses, and Geeks Created the Digital Revolution, describes very well how this culture originated in HP in the early 1940s and later spread through other tech companies such as Intel in Silicon Valley. Bill Hewlett, in defining the HP way, said, "We believe people want to do a good job, and we're going to provide them that opportunity. We are going to provide them the right environment, but then trust that they will achieve the right business goals. We believe the people closest to the problem will have the best solution. We will not micromanage them. We will define the high-level strategic goals, but empower people closest to the problem to come up with the right solution. We also believe that people are our most valuable resource. If we succeed as a company, our people should succeed." They backed this up with a very enlightened profit-sharing program and employee stock program at a time when this was almost unheard of. It breaks my heart that in the early 2000s, with new management, very large mergers and acquisitions, much of this amazing culture began to be dismantled. Other Silicon Valley companies also seem to depart from this enlightened model, but the most successful tech companies of the past 10 to 15 years, Google and Apple, have kept this culture alive and well. I think keeping this culture alive was a big part of their success. If we are subcontracting much of the project work to vendors, and we have very little past performance information for these vendors, then Agile is not a good fit. We will need a detailed SOW with all the I's dotted and T's crossed. 2. Large, complex projects with many stakeholders and stakeholder groups. Difficulty finding the right product owner who can resolve conflicts. Jeff Sutherland describes several projects 16, the FBI Sentinel project, Medco, etc., which were all in crisis and failing. But in all these projects, there were a large number of stakeholders and stakeholder groups that had disparate needs and wants that were not compatible, and the projects were stuck in a deadlocked position. The stakeholders were at loggerheads about what should be included in the project and what the priorities should be. One of the first goals in transitioning to Scrum is to simplify this type of situation. For the FBI Sentinel project, they reduced the staff from 220 to 40 and reduced the number of FBI employees on the project from 30 to 12. The next step focused on prioritizing the requirements, or the product backlog, and identifying the 20% of the requirements that would achieve 80% of the need. Having the right product owner, if that can be achieved, will definitely help resolve deadlocks in choosing what should be included in the product backlog and the priorities of these backlog items. But on some very large, complex projects, it may be necessary to have multiple product owners, and, of course, that can present problems too. Someone has to have the final say and be the decision maker. And if the right product owner is not selected, and if senior management ends up vetoing what the product owner had previously approved, but only after 3 or more months have passed, then we will have wasted a tremendous amount of time and a lot of money, and Agile didn't work the way it was intended. So, it might be difficult to find the right product owner or customer in XP. A key assumption for Scrum, or for XP, is that we can find the right product owner who will effectively resolve the conflicts between incompatible requirements for what will be included in the project and define PRI ORIDIs. But on a large, complex project with many powerful stakeholders, it may be very difficult to get agreement and get all the stakeholders to buy into what the product owner has decided. Again, as we described earlier, this is the hard part of project management. Whether it is a PM or a product owner striving to get agreement on inconsistent, payable requirements, this can be a very tough challenge to handle. Many large, complex projects and programs, F-22, Affordable Care Act website, etc., have failed because this wasn't handled correctly. No matter what powers have been given to the product owner, there will be many other stakeholders on the project, e.g., the sponsor, the customer, other senior managers, federal regulatory agencies, that outrank the product owner. The skill sets the product owner must employ to get everyone onto the same page are soft skills, negotiation skills, communication skills, facilitation skills, and so on. Following a particular process or even a methodology will not guarantee success in achieving this goal. This is about the EQ part of the equation, not the IQ part. 3. We are in a cookie-cutter type project and have successfully done very similar projects like this one many times before. There were only small customizations differentiating the projects. Again, does that mean this type of project is easy? No. However, if we are in a cookie-cutter type project, it will be far less expensive and more efficient and practical to use the traditional approach. We don't need to discover and explore requirements. The customer knows going in exactly what they want for this project. We need a traditional SOW where all the I's are dotted and T's are crossed. E.g., a young couple is remodeling their kitchen, and the key stakeholder, the wife, of course, knows exactly what she wants going in, the make and models for the different appliances, the exact type of cabinets and countertops, etc. 4. We are handling an emergency situation, and there isn't time to explore or discover requirements. There isn't time to prototype. There might not be time to canvass all the stakeholders and exhaustively detail all the requirements either. We may be in the type of situation where a less than optimal decision made now at the right time is better than the perfect decision made too late. 5. We have only one chance to do this project, and we have to get things right the first time, e.g., again, perhaps an emergency rescue mission, Apollo 13. 6. Places where more central control is needed. The classic PMP fully accountable PM is needed. Perhaps this could be for an emergency situation or a military operation. There isn't time to debate different solutions. We need the team members to follow through on the plans being disseminated by the PM. 7. If the team members are multitasking on a number of projects at the same time, are only able to perform very specialized tasks within their range of expertise, and are only working part-time on the project, then Agile probably isn't the best fit. 8. If the team cannot come up with an MVP, minimum viable product, to demonstrate to the product owner and customer in the early iterations, Agile is probably not a good fit. For a large, complex project, it might take a development team many months to tie together all of the infrastructure and hardware before any kind of recognizable demo or MVP can be made. In the early iterations, it might only be possible to demonstrate something using prototypes or models with fake data. Engineers and customers could sit side by side with the product owner and customer, discuss the prototype, and talk abstractly about what features the customer would like the real product to have or how they would like to use it. But then there will often be a large effort and a long period of time to get a real working product created that is usable by customers. These planning phases of the project could take months, and a predictive planning approach will probably be needed. In this situation, we cannot effectively use lean and agile. We are relegated to using a traditional, predictive planning approach. When you have an MVP or demo that uses real customer data, that is the type of project where you can meet with the customer in the first iterations and effectively use lean and Agile. 17 other key risks where Agile provides extra help. It's a well-known maxim that when projects fail, they fail at the very beginning. We said that having a poorly written scope statement, which stemmed from not doing requirements well, was the number one cause of project failure and was, therefore, our number one risk. As we said, this often stems from not doing requirements well and not being on the same page with the customer and senior management. This is certainly something that hits many projects right at the very beginning. We saw how using lean and agile methodologies can help us handle this risk. By going after the top priority requirements first, 20% of the requirements that will fulfill 80% of the business need in the first iterations of the project, we are addressing this risk. By increasing the frequency of the feedback loops and speeding up the PDCA loop, we are addressing this risk. There are 3 more key risks that also occur right at the beginning of projects that Agile can help us solve. 1. Allowing half-baked ideas to survive and not doing kill points well. 2. Handling impossible constraints or dealing with the impossible project. 3. Poor communications, not keeping senior management in the loop and up to date on the project. 1817. I would like to thank Jason Vorenkamp for providing this important example. Jason said it was fairly common to run into this issue with a number of IT projects where they were using Agile. 18 again, I'm being a little bit lazy in describing these 3 items all as risks. If any of the items involve uncertainty and are something that could happen in the future, then they are risks. If the problems have already occurred, they are no longer risks, they are issues. Agile will help us in handling these, no matter whether they still are risks or are issues. Risk number 2, allowing half-baked ideas to survive. If we are worth our salt at all as PMs, we are focusing very heavily on managing risk. We are doing this at the very start of the project and also all throughout the project. Risk management must be focused on, iteratively, throughout the project. If we don't do this, there is no way to be proactive and no way to issue the favorite type of change request for PMI, preventive change requests. If our team members are not on the lookout for triggers of negative risks, then there is no way we will be able to put into action strategies for avoiding these negative risks, mitigating negative risks, or transferring negative risks. So, doing risk management is absolutely fundamental and necessary on all projects. We are also focusing on risks in a number of different categories, and we are using a risk breakdown structure, RBS, to help us identify risks in these categories. Early on in my career as a PM, I used an RBS that started with risks at the top, and then, in the next level down, I broke risks into internal risks and external risks. So, we can make that type of structure work fine. But what I prefer today is the RBS Figure 1.9 Doug DeCarlo uses in his book Extreme Project Management. The second level in DeCarlo's RBS is divided between 1. Business risks, 2. Product risks or technical risks, 3. Project risks, and last, 4. Organizational risks. Business risks are all about the risks of profit and loss, what senior managers and our sponsor are most focused on. Is the idea of this project totally half-baked? Are we going to make a profit or are we going to lose our shirt? Is this something that we are good at? How's the economy? Is this a very tough competitive landscape? Is this a highly regulated marketplace? We are focusing on those types of questions. Too many times, companies go after a totally half-baked idea or some senior manager's pet project or something that we are really clueless about. This is a very dangerous situation. If management allows such half-baked ideas to survive, then very valuable resources and funding are being taken from other much more deserving projects. This can even lead to the downfall of the entire company. So, we need to find out about the validity of a project idea very early on in the game and kill the project if it is a half-baked idea. By the way, if we are asked to manage a project that is totally half-baked, is this mostly a risk just for senior management and the sponsor, or is this a big risk for us too? Again, an obviously rhetorical question. Of course, this is a huge risk for us as PMs. This project is certainly bound to fail, and when it fails, who is going to take the blame? Who is going to be looking for a new job? You know the answer, and it's not the sponsor who came up with the half-baked idea. Before I move on to talk more about business risks and half-baked ideas, let's talk briefly about the other 3 major categories of risk in this RBS. The second category, product risks or technical risks, is focusing on questions such as, do we have the resources and skill sets to create the product with the right quality? Are the requirements and the quality metrics for these products clearly defined and specified? Are they smart? The third category, project risks, is primarily focusing on constraints. How tightly constrained is this project? Are there very tough budget constraints, schedule constraints, or resource constraints? Have we correctly identified the priorities of the triple constraints? Also, do we have the right PM with the right experience? The last category, organizational risks, is all about political risk. We are creating something new and unique. Yes, that is what a project is all about, creating either a new product, a new service, or a result. That's the definition of a project in the PMBOK guide. So, is everyone in our organization in favor of this project, this new thing we are trying to create? Of course not. Some people are losing power and influence because of our project. They are not in favor of this project at all. Many people resist change and just don't understand change. They are saying things like, what was wrong with the way we used to do things? Or, I like the old way. They are not in favor of this project either. So, when we created our stakeholder management strategies, we should have focused on these stakeholders and tried to put together strategies to turn the more negative stakeholders into supporters of the project, or at least neutralize the negativity. Back to half-baked ideas, kill points, and handling business risks. When I obtained my PMP certification in 1995, the requirements for contact hours, or education hours, were more stringent for the PMP certification. Therefore, HP sent me to a 2-day conference on project management held at Boston University, so I could obtain the necessary contact hours. There were more than 25 different presentations delivered, some simultaneously in different rooms, over the 2 days, and prizes were awarded for the best papers. The first prize went to 10 dumb mistakes that project managers make by Gopal Kapoor. The number 1 mistake that he listed was allowing half-baked ideas to survive. Classically, when product managers and the business development team are working with senior managers to do project selection, they are using financial selection techniques such as net present value, NPV, internal rate of return, IRR, opportunity costs, payback period, economic value add, EVA, and other methods to see what project will have the greatest return on investment, ROI. Mr. Kapoor's point was that all too often, these techniques are only used once to select a project out of a possible group of projects, and then management never reanalyzes things or reexamines things to determine if the business case still exists for the project. His point was that this should be done multiple times through the course of the project lifecycle. Perhaps this should be done at the end of every phase to see if we think we will still get the best ROI with the project. As we move through every step of planning, we are progressively elaborating and decomposing high-level business requirements and functional requirements down to more detailed products, and more detailed products down to parts and components, and parts and components down to specific activities. Therefore, we can obtain much better estimates of time and cost each step of the way and also improve our forecasts for the project. These better estimates and forecasts should be fed back into the financial analysis techniques so we can determine if the business case still exists. Many companies do not do this at all or do not do it well, and this can lead to immense problems. We want to ensure that we aren't attempting to create something half-baked that has very little chance of being on time, within budget, and having the desired value for our customer. In Figure 1.10, we are showing kill points occurring regularly as we move through the project phases. Agile is helping the product owner, senior management, and the team accomplish the kill points in a much more effective way. First, the kill points can occur much earlier and much more frequently. Review meetings with the product owner and management are occurring at minimum on a monthly basis, but oftentimes are occurring much more frequently than that. Management and other stakeholders are encouraged to come by the area where the team is working on a frequent basis to review the information radiator that displays the burn-down chart, a Kanban board, and other key information on the project's progress, so they can discuss the project and ask questions. More than that, something empirical and tangible is being produced in each iteration, and as we've said, this is much more valuable than only producing dashboard reports displaying S-curves, network diagrams, Gantt charts, or other forecasts. When we're in the type of project where the customer doesn't know exactly what they want going into the project and we need to explore and discover the best solution, providing something empirical that the product owner can touch, experiment with, and use will be especially valuable. Again, we could be in the world of I'll know it when I see it or a Kawisi. Risk number 3. Impossible constraints. A type of risk closely related to the problem of a project dealing with a half-baked idea is the problem of dealing with the impossible project. I think all PMs have been put in the situation where the sales team has thrown a new project over the fence to them with an impossible schedule constraint, or similarly, senior management imposes upon them an impossible budget constraint for a project. These risks fit into the category of project risk in our earlier RBS. Unfortunately, all too often, the salespeople and the management team did not bring the PM into the pre-sales process fully and did not ask for the PM's opinion early on for figuring out what was realistic for the project and what could be achieved. In today's world where the competitive bar has been set very high, customers are more fickle than ever, and the marketplace is changing so fast it makes your head spin. This scenario is far too common. PMs are being asked to manage the impossible project. The PM is left wondering, what were they thinking, and how in the heck did they expect that this project could get done? I wish they would come and try managing this project. When the senior manager asks the PM, now, you can get this project successfully completed. Yes, you can get this project completed on time and within budget. Yes. What's the right answer? Is it, sir? Yes, sir. I know you have given us a very challenging schedule here, and of course, not all the resources we would like to have, but I am very confident in our team, and I know the team, and I will be successful in meeting your goals. And then, at this moment, I'm not quite sure how we will pull this off, but with hard work, I know we can succeed, and we will succeed. Is this the right answer? Of course not. Management does not need some Pollyanna, glib answer. They do not need a yes man to tell them what they want to hear. That isn't going to do them any good at all. They do need some type of reality check and good advice on what can realistically be expected with the project. So, what is the right answer? And this answer applies to either the traditional waterfall model or the agile model. The answer is, I don't know yet. We need to do some more planning and investigation to determine what can be accomplished, and in what time frames, and for what cost. The team and I will do this more detailed planning, but I will get back to you soon with much better estimates of time and cost for what we are confident we can accomplish. What would our approach be using a traditional waterfall project lifecycle? As we said before, we would just follow the sequence of planning processes that are laid out in the first knowledge areas in the PMBOK guide. As we've already described, we would take the initial description of what product or service best meets the business need from the project charter, plus the initial estimates of time, cost, resources, and risk, and we would start drilling into more detail. We would do the process, collect requirements, very well, ensuring that we did not miss any requirements, misunderstand any requirements, or miss any stakeholders. We would then do the process, define scope, and define boundaries and exclusions for our deliverables and make sure that everyone is on the same page for this project. However, we wouldn't stop there. We would keep going deeper into what PMI loves best, create WBS. Then, we would go down to the activity level with our scheduling processes. All along, we've been improving time estimates and cost estimates for budgeting. Each step of the way through planning, we are drilling into more and more detail. We break down high-level requirements into specific deliverables, then down to parts, and then to components of parts. We will know resources much better. So we can provide much better estimates of time and cost. On a large, complex project, how long is this going to take? Probably several months at minimum. Is management going to be patient with us over these months, waiting to get the better estimates of time and cost? Of course not. They're knocking on our door every few days demanding these better estimates. We are doing our best to oblige, using estimating techniques described in the PMBOK guide, analogous estimating, bottom-up estimating, parametric estimating, and three-point estimating. As we move through the sequence of these planning processes described above, we are understanding our products and deliverables in more detail each step of the way, breaking things down to the part level, component level, and then the activity level. So each step of the way we can obtain more accurate estimates of time and cost. In addition, we will use the analytic techniques described in the process, perform quantitative risk analysis, by first obtaining probability distributions for time and cost for work packages, or even the activities in the schedule, and then using Monte Carlo simulation to mathematically determine the right level of contingency reserves that should be included with activities that will roll up to the schedule baseline and the cost baseline to help protect the project from risk. Therefore, we will be able to get a more accurate forecast of when this project is likely to finish and a more accurate budget forecast. Alternatively, we may choose to use EMV to refine the contingency reserves. Using these estimating methods and other analytic tools and techniques, we will have created a very impressive network diagram showing the dependencies between the thousands of activities in the project, the critical path for the project, and the float for all the activities in the network diagram. Using Monte Carlo, we could create a very impressive S, curve 19 showing a probability distribution of projected costs for the project, and then we could explain to management what this implies for our level of confidence of meeting certain schedule objectives and cost objectives. We could create a tornado diagram that shows what work packages are most sensitive to what risks. Doing all this planning and creating all these charts that took months and months can be very seductive and create some very impressive charts and documents. But how accurate and how reliable will all these charts be? How accurate will our forecasts be? In our modern project world, with so much change and volatility, it is very rare that these will be accurate. As Jeff Sutherland describes in his book on Scrum, it's just so tempting to draw up endless charts. All the work needed to be done on a massive project laid out for everyone to see, but when detailed plans meet reality, they fall apart. Build into your working method the assumption of change, discovery, and new ideas. Several other excellent quotes also bear on this subject. To fail to plan is to plan to fail. Yes, very true, but also, planning is useful. Blindly following plans is stupid. Planning for combat is important, but as soon as the first shot is fired, your plans go up in smoke. Dwight Eisenhower, no plan survives contact with the enemy. Helmuth von Moltke the Elder, Prussian general, in an interesting book, The 6 Dimensions of Project Management, Turning Constraints into Resources by Michael Dobson and Heidi Fikert, the authors describe how we can sometimes solve the impossible project by figuring out which of our triple constraints has the highest priority, which is second in priority, and which is third, and then, using creativity and one's imagination and by being proactive, we might be able to exploit one of these constraints or project assumptions. They point out examples of situations where it was assumed something was a fixed constraint, but by being proactive, using creativity, and thinking out of the box, it was discovered there were assumptions buried in the constraint, and using creativity, the assumptions could be changed and the supposed constraint could also be changed. The constraints weren't really constraints after all. This should be reminiscent of the Standish survey and the point made previously about requirements. 65% of the requirements the customer thinks are absolutely necessary will never be used. In our projects, it often turns out that requirements that were thought to be absolutely necessary are found not to be needed. Therefore, Agile methodologies will provide a much more effective and faster solution for probing what is really an assumption and what is a constraint point 20 by going after the highest priority requirements in our first iterations. The 20% of the requirements that will fulfill 80% of the need, and also the requirements with the most risk, and then by creating something tangible and empirical that can be demonstrated to the product owner and the customer and other senior managers. We should be able to solve problems with impossible constraints much more effectively. We will see very early in the project what has value and what has not. Things that don't have value will be taken out of the product backlog, and we will not invest in them further. As we said before, this is going to save time and money. Demonstrating something tangible and empirical to our key stakeholders also provides a much stronger reality check on the value of what's being created. Doug DeCarlo's quote, "If a picture is worth 1,000 words, a prototype is worth 1,000 pictures." As we saw in the Medco example earlier, using Scrum or another Agile methodology and using lean approaches can solve the problem with handling an impossible constraint. Even if we find out that what we are trying to achieve is truly impossible, and this cannot be accomplished in the right time frame for the right budget and meet mandatory scope and quality requirements, then at least we have determined that very early in the project, in the first iterations. We can provide the product owner and senior management the information they need to make an informed decision on whether or not they should cancel this project. That may be the best thing to do in a number of cases. The project team may be very discouraged with this outcome, but it might be the best choice for the company. Increasing the frequency of the feedback loops and speeding up 20 by the way, the pure definition of a constraint for PMI is constraints are things that are given to us from the outside and limit our options for planning. These are things that are known or are facts. There are 6 classic constraints: scope, time, cost, resources, risk, and quality. Or, we can have constraints in any of the 6 areas. For PMI, in contrast, assumptions are things that we assume to be true for the time being that will guide planning. At the beginning of my project, I often make assumptions about resources and what training is required for my resources, or what tools and equipment will be required for my resources. I may assume going into the project that my resources won't need more training or won't need new software or new tools. We always need to re-examine our assumptions as we are moving through the project. The PCA loop also helps management in making better decisions with the kill points. As we said previously, many companies don't do these kill points very well, and this can lead to huge problems. Even while using traditional project management approaches, the importance of getting off to a good start is well known. In the literature, it's well understood that the number one risk we face is not getting off to a good start, not obtaining requirements in the right way, and not having a well-written scope statement with boundaries and exclusions and smart acceptance criteria for our deliverables. EVM, which, as we've said, is very consistent with traditional waterfall project management, also understands this very well. In Fleming and Koppelman's book, Simple Earned Value on All Projects, simplified translations of the 27 EVM criteria, they point out that it's most important to use EV, get the key measurements of schedule variance, SV, cost variance, CV, cost performance index, CPI, and schedule performance index, SPI, and also get our forecasts, estimate at completion, EAC, and estimate to completion, ETC, very early in the project lifecycle. We really need to get these EV measurements no later than 15 to 20% into the project schedule. Point 21, it's only at that point where we have some hope of making the necessary corrections to save the project. If we are more than 1/3 of the way through the project and we discover that CPI is significantly below 1, e.g., 0.8, then it's too late to make the corrections. To complete performance index, TSPI, will be some number like 1.2, which is saying we need to make a 40% improvement in our budget performance to get back to the original budget, the original BAC. That is not possible, and there is a small chance out of no chance of that happening. They point out that there is a wealth of data on federal programs, many of them large DoD programs, where it is shown that once you're more than 15% through the project schedule, it's next to impossible to make more than a 5 or 8% improvement in CPI or the budget performance. So, to be useful for us, EVM must be used very early on in the project lifecycle. Agile methodologies are providing the same type of performance measurements very early in the project lifecycle, even in our first iterations, using burn-down charts and burn-up charts. These are much more intuitive and easier to understand than the EVM dashboard, which is typically an S-curve showing all the EVM variables, planned value, PV, earned value, EV, actual cost, AC, budget at completion, BAC, and also showing forecasts, estimate at completion, EAC, and estimate to completion, EDC. There are few senior managers who will understand the intricacies of such an S-curve, but almost anyone is quickly going to grasp what a burn-down chart is indicating and will be able to make the appropriate inferences to see when we're going to end up with this project. A classic S-curve chart 22 is given in Figure 1.11 and a classic burn-down chart in Figure 1.12. The dashed line on the burn-down chart is showing us our plan for creating work or creating story points. Thus, the descending dashed line is showing us the remaining PV in the project or in the release. The solid line is showing us the work we've actually created, or story points actually created, so this is showing us EV, actually, the remaining EV as the line descends. AC is also easy to derive as the costs for each iteration are fixed, since these are essentially the labor costs for each iteration. Though we didn't show it, this would be a diagonal line running from the bottom left to the upper right, the opposite direction of the dashed line. To stay consistent with the theme of the burn-down chart, we could make the AC line a descending line that is showing us costs remaining in the project. Again, the costs should be fixed for the project or the release. Risk number 4, poor communications, not keeping senior management in the loop and up to date on the project as PMs. We all know how important it is to do communications very well on our projects. Our most important skill set as a PM is communication skills. As we've said, a huge part of this is good listening skills. All good communicators are necessarily good listeners. A big part of good communications and good listening skills is paying close attention to all the undercurrents involved in the communications, all the body language. Again, I think 90% of good project management is really about emotional intelligence, the EQ part of the equation, not the technical part or the IQ part of the equation. For almost every project I've encountered that was failing and in crisis, there were serious communications problems. What does senior management, and the customer, too, hate most? Surprises. Negative surprises. But not keeping them up to date on the progress and the good things happening with our project is also a dangerous mistake, especially not updating our sponsor. If we have not kept her in the loop on progress being made and our success, then out of sight is out of mind. Other priorities might have come up, and she might have shifted her focus elsewhere. We might find she has decided to shift resources or funding from our project to something new. On a critical project I managed at HP, one of those impossible projects, in our internal kickoff meeting, the sponsor said to the team, "It will not be enough to just communicate well on this project. We must over-communicate." So, what did he mean? This project was a special project with an incredibly demanding goal-live date, $80 million plus at stake, a very difficult external customer to keep happy, a very large number of key stakeholders, other business units inside of HP, and also key vendors to whom we had subcontracted major portions of the project. How many times in your project do you believe you have done all the necessary things to get agreement between key stakeholders on an important date, or a requirement, or item, or decision, and things still went wrong? You ensured minutes were taken of the meeting where the agreement was achieved, and the minutes documented that everyone agreed with several key decisions. The minutes were disseminated properly to all the key parties soon after the meeting, and yet, somehow, things still did not go smoothly. You asked all the attendees of the meeting to review the minutes and report back by the end of the next day with any corrections or edits. Then, a few weeks later, a key stakeholder says, "No, I didn't say that," or, "That is not exactly what I meant." Sometimes, when we get the answer, yes, on a key point, we need to double-check with that stakeholder a few days later and make sure the answer is still yes. I believe this is what the sponsor meant by saying, "We must over-communicate." This is probably not necessary on all projects, but at some time in your career as a PM, it will be. In Gopal Kapoor's presentation, 10 Dumb Mistakes Project Managers Make, the number one mistake was allowing half-baked ideas to survive. The number two mistake was not keeping your sponsor and other key stakeholders in the loop with key status information on the project. He termed this overlooking stakeholders, forgetting the champions, and ignoring the nemesis. We have already seen how Agile really helps in key ways with improving communications for our project. We've described that with using Agile, 1, we are communicating with the product owner, customer, and other key stakeholders much more frequently. Review meetings are occurring at minimum on a monthly basis, but collaboration with the key stakeholders is expected to be occurring more frequently than that. 2, communications between all team members are occurring much more frequently. Daily stand-up meetings with the team members are an excellent tool for improving communications. Every team member gets to hear how things are going with all the other team members, what problems they're facing, and what progress they're making. When they hear of a problem another team member is having, it is likely that one of the team members is going to have some suggestions. This is taken offline and not handled in the stand-up meeting, but this will very likely help improve progress for the project. Retrospective meetings that are held at minimum in each iteration are also excellent tools for improving communications and improving the team chemistry. At heart, these are just lessons learned meetings. These retrospective meetings are for the team members and ways for them to improve their processes. At the end of each sprint, iteration, they are asking, what worked well? What didn't work so well? What should we do differently in the next sprint? The frequency of the feedback loops is dramatically increased. Agile is speeding up the PDCA loop, and this is speeding up communications. 3. We are demonstrating tangible, empirical product increment to the stakeholders. This is more compelling and powerful than just reporting our project dashboard in S-curves, progress reports, status reports, forecasts, or other EVM reports. 4. The Agile reports. The information radiator is low-tech and high-touch. These reports, such as a burn-down chart, burn-up chart, Kanban board, and reports showing the team's velocity are intuitive and easily understood. It's a very rare customer or senior manager who understands all the vagaries and details in an EVM S-curve. On the other hand, they will readily understand a burn-down chart, Kanban board, or reports showing velocity. 5. What management cares most about are our forecasts. They do care about our variances, our CPI, and where we are today with the project, but the question most on their mind is, when will you really be done? And of course, how much is this project really going to cost when it's all said and done? That is the reason cost forecasts are the most important output of control costs, and schedule forecasts are the most important output of control schedule in the PMBOK guide. It is far easier to forecast using a burn-down chart or burn-up chart than to do forecasting with Monte Carlo or EVM. 6. Using dedicated teams that are co-locate will improve communications in very significant ways. If the team is co-locate, what did we just get rid of? Phone tag, delays, and waiting for responses to email messages. Also, how many times have you received an email from a key stakeholder where you thought everything was under control and you were on the same page together regarding the project? You read this email, and it's obvious that you're not on the same page. You are reading the email, and parts of it are very confusing and obscure. You're wondering why they said things the way that they did, and you know there's some type of problem, but you're not really sure what that problem is. In the world in which I managed projects, it's very unlikely that I'm in the same office with this stakeholder. I'm going to have to pick up the phone and, hopefully, get them on the phone right away and try to get to the bottom of this problem. But more times than not, I'll reach their voicemail and I'll have to leave a message. Then I'll be quite frustrated for at least several hours until we can get to the bottom of things. If I'm in an agile environment where the entire team is co-locate, I can just get up out of my chair, go find the stakeholder, and we will quickly get to the bottom of things. What's the key factor that's really going to help me cut through any possible confusion and nonsense? Being able to see the body language of this other stakeholder is key. Being able to see their expressions and hear the tone of their voice will be vital in ensuring that we are on the same page. In a classic agile environment, I can get all of that. As Susan Parente discusses in the chapter on virtual agile teams, we will need good tools like Zoom, GoToMeeting, Google Hangouts, Join Me, Adobe Connect, and Skype so the team can meet virtually, but still have video and audio real-time connection with each other. How do we make hybrid approaches work? Hopefully, most of the project management world has embraced Agile today and understands the need for its use in solving modern project management problems. Agile is the elephant in the room for doing project management. Yet, there is still a need and a place for using the tried and true traditional waterfall approach as well. Waterfall shouldn't be discarded and forgotten. But now, the hard part comes. How can we marry these two approaches and effectively use them together in projects and programs? I don't think this is going to be easy. Many people in the Agile community think of hybrid projects in quite a negative way. They think a hybrid approach corrupts Agile and, therefore, should not be used. They would say if you attempt to mix Scrum and Waterfall, you won't get Scrum plus Water plus Fall. Instead, you will get Scrum plus Water plus Fail. 23 in large part, I don't disagree. If you attempt to use Scrum and Waterfall/predictive approaches within the same portion of a project or sub-project, e.g., use Scrum, but also try to use a Gantt chart to define the critical path and schedule 24 for the next 6 to 9 months, you will likely fail. But if you completely separate the waterfall/predictive pieces of the project or sub-projects from the Scrum/Agile pieces and handle each independently of each other, then I think this can work and it makes sense to do so. In fact, it is often going to be necessary. In my experience, management within my own company would not allow me to use Scrum or Agile on all projects or sub-projects. It would be far too expensive. They would not support having dedicated teams of 5 to 10 senior engineers or generalizing specialists on all parts of my projects. Again, that would be far too expensive and impractical. I'm going to have to work hard to get their buy-in to use Scrum or another Agile method on some high-priority sub-projects or portions of projects. Also, I'm going to have to work hard to educate them that, for these sub-projects, they're going to have to be much more involved, and they are also going to have to support a new culture. Yet, this might be a hard sell to both the Agilists in our organization and those who favor the traditional approach. Some Agilists say that a company cannot adopt Agile halfway or partway and, therefore, can't allow for hybrid projects. It's an all or none affair. If you try to immediately use a hybrid approach, you will risk failing at adopting Agile. Your Agile project will fail, but it wasn't a defect in the Agile methodology. It was a failure in the way in which it was implemented. The Agilists will say this is almost like converting to a new religion and something we must do for the whole company. Obviously, that's very hard to do, and it will be difficult for the organization to make this transformation. Jim Highsmith, one of the key authors of Agile articles and books, says, "Stop doing Agile. Start being Agile." I believe a big part of what he means is that it's a mistake to adopt some pieces of Scrum and other Agile approaches, e.g., incorporating daily stand-up meetings, having an information radiator, calling your requirements the product backlog, but not fully embracing the entire Agile approach and culture. Of course, he means that the entire company must do this. He also means don't follow Scrum practices halfway or in name only. Doing so is called being Agile in name only, ANO. Yes, it is so common there is an acronym for it. In other words, don't do daily stand-up meetings, but make the daily stand-up meeting the same as the traditional weekly status meeting. Don't say you are going to adopt Agile, but then require that the traditional PMO policies stipulating the team must use MS Project to build a network diagram and define the critical path stay in place. Don't do this for the parts of the project where you are using Agile. Don't require all the normal project documents, all 30-plus project documents defined in the version 6 PMBOK guide, such as a risk register, stakeholder register, and issue log be developed. Yes, some may be needed, but these should be evaluated on a case-by-case basis. If they are needed, it should be because they provide value to the customer, which includes whether they are needed to meet regulations or standards the customer requires. Far too many people say they are using Agile and they are totally on board with it, but then it turns out they are using it halfway or in a corrupted manner. So, the risk of this occurring is even greater when we venture out to use hybrid approaches. There is a real danger that we will not get the best of both worlds and instead get the worst of both worlds. Yet, there is a danger of this happening no matter what project management approach or methodology we use. PMs are always finding ways to not do communications well, not run meetings well, not obtain requirements, not plan well, not treat the team members well, or not pay attention to important contract obligations, and so on. Trying to follow a particular process or a methodology won't guarantee anything. However, using a hybrid approach is about finding optimum ways of communicating well with our team members and customers, running efficient and effective meetings, obtaining requirements that add value for our customers, soundly planning and executing to deliver on features that add value to the customer, treating team members and other project stakeholders well, prioritizing them over processes and procedures, paying attention to important contract obligations, while effectively collaborating with the customer. There are two different ways of referring to hybrid Agile projects. 1. The first approach is not controversial, and it refers to mixing different Agile methodologies, such as Scrum and XP within one project. This topic is worthy of a long discussion, and in fact, today, there is plenty of discussion on using hybrid approaches by scaling Agile methodologies throughout the enterprise, especially within programs. Two of the most popular frameworks for scaling Agile in a hybrid way are Scaled Agile Framework, SAFe, and Disciplined Agile Delivery, DAD. These frameworks are primarily focused on scaling Agile methodologies for software and IT projects and defining processes for using Scrum, XP, Lean, Kanban, and DevOps. However, a number of authors think SAFe and DAD impose too much structure, are too prescriptive, and therefore are too restrictive. For example, Googling "Does SAFe Agile impose too much structure?" results in a number of articles that argue for this position. Again, no one process or methodology fits all situations, and these frameworks may take away the freedom that project teams need for determining the right methodology in the right situation. Another objection that is often voiced is the idea that teams should give one methodology, for example, Scrum, a good 9 months or longer before venturing out and mixing in other Agile methodologies. Key authors of Agile/Scrum articles say, yes, Scrum is easy to adopt, but it's hard to perfect and excel in using. So, give it a good try on its own with the basic team roles along with the basic meetings and rituals before venturing out and adding any other elements. Lastly, I find it very interesting that neither SAFe nor DAD allows for integrating traditional waterfall approaches within the hybrid framework. Why wouldn't they allow for that? If some projects or parts of projects involve work we've done many times before and for which we have very good historical records of time and cost, if the customer knows in detail exactly what they want starting out, won't it be less expensive and more efficient to use a traditional waterfall approach for these parts? I think the answer is clearly yes. I think many of our projects today are large enough and complex enough that parts of the projects are work packages that we have done many times before, and these parts are cookie cutter. It will be simpler, less expensive, and faster to handle these cookie cutter parts with a traditional waterfall approach. We will expand on this discussion throughout this book. 2. The second meaning of hybrid project management is jointly using an Agile approach with a traditional waterfall approach within the same project, and this is the controversial topic. Can this be handled effectively? What are the key obstacles and challenges? As I've said, many people in the Agile community think it is foolish to attempt to do this. I think it is necessary in many corporate environments today, and we need to find ways to make it work. I would like to argue that as long as the Agile components are kept separate from the traditional/predictive components, then this can work. What are the main difficulties? Let's go through the problem areas for Agile that we described in the previous section and see how some of these problems map into managing a hybrid project, mixing components that are Agile with components being handled in a traditional/predictive way. First and foremost, we said the right stakeholder relation, ships and culture in the organization must exist to support Agile. Agile is not as much a project management methodology for how to best obtain requirements and divide a project into phases or stages as it is a new culture and mindset. To just make Agile work successfully on its own, as we've described, a culture of freedom and trust must be provided to the team members. Senior management must buy into this idea, understand they have a key role to play, and get at least a basic education in Agile. They must realize that they will need to be much more involved than they would in a traditional, waterfall environment. So, to make hybrid work, where both programs and projects contain both traditional pieces and Agile pieces, is going to be even more challenging. I think it's going to be paramount to provide this Agile culture or Agile mindset across the entire hybrid project or program, not just the Agile pieces. It would be impractical and even offensive to handle some parts of the project or program with an entirely different management approach than other parts. Again, senior management and the entire company must be supportive and buy into this idea. Also, everyone must understand it's a mistake to mix the two approaches together on the same sub-project or portion of a project. It may seem overly idealistic and utopian to provide this type of culture company-wide, but it is very possible. In fact, many tech companies such as Apple, Google, and Intel are doing this today. They are providing this culture of the agile mindset throughout the company, in programs, projects, and even for operational functions. Allowing for much freedom and trust for employees doesn't simply imply that one person's ideas are as good as everyone else's, that the employees are free to do whatever they want, or work on whatever they want. No, quite the contrary. It's understood that striving for value is paramount, and we will use lean techniques to quickly identify waste and remove it from the product backlog or work assignments. By using Agile and Lean, we are focusing even more efficiently on achieving value and eliminating waste than we would in a traditional company structure. If the company's culture is to use Scrum or another Agile methodology on all projects, then it might be difficult to sell the idea of being flexible and allow some projects or parts of projects to use a traditional approach. Both senior management and the project management team members themselves might be pretty resistant to that idea. Likewise, if the company culture or the PMO culture is to use a waterfall approach and EVM on all projects, then it could be difficult to sell people on the idea of integrating an Agile for some projects or parts of projects. But as I've said multiple times, it makes sense to be open-minded to this. We should recognize that there isn't one perfect process or approach for solving all problems. For almost any type of job, we have to learn what's the best tool and for what situation. So, everyone on the hybrid project needs to get basic training in the Agile method being used, and also basic training in the nuts and bolts of traditional project management and why it is still necessary today. We need to send senior managers to this training also. How do we organize all the different components in the hybrid program/project? How do we ensure the Agile components are managed separately from the traditional components, but all the pieces are integrated together cohesively? As we've described, many of our modern projects are big enough and complex enough that some parts of the project, some work packages, if you will, are cookie cutter, and it makes perfect sense to use the traditional waterfall approach for these parts. As we mentioned earlier, it's going to be less expensive and more efficient to let the classic fully empowered PM run the show, be accountable for all planning, all executing, and all monitoring and controlling. This PM will hand out parts of the PM plan to individuals on the team, will ensure they execute against the plan, and will also be accountable for measuring variance, measuring progress, and doing forecasting. Having a co-locate team of 5 to 10 senior individuals dedicated to the project is a much more expensive option. This is especially true when we know, going in, exactly what the customer wants. However, for the parts of the project where the customer does not know exactly what they want when starting out, and there will be a premium on discovering requirements and a premium on creativity, one of the Agile approaches would be best. This is also true for projects where some of the other risks we have discussed apply, handling the half-baked idea and handling impossible constraints. How can we best integrate different approaches in a hybrid model? Ken Schwaber, in his book Agile Project Management with Scrum, describes an ingenious way of using Scrum all by itself for fairly large, complex projects. If we have a project that's large enough where we are going to need 50 or even more project team members, then he says divide the project into multiple Scrum teams and divide the project work between these different teams. Then, to integrate and coordinate all this work and handle dependencies, have a representative from each Scrum team meet with the other teams in a Scrum of Scrums meeting. His graphic for this Scrum of Scrums meeting looks something like that in Figure 1.13. The Scrum of Scrums meetings may function in a very similar way to the daily stand-up meetings of a normal Scrum process. But in the Scrum of Scrums meeting, the team members will only discuss stories or features where there are dependencies with stories and work the other Scrum teams are doing. Like a stand-up meeting, the purpose will be for each representative to provide their updates/status to the other team's status and progress, and also review dependencies between the team's work. Let's take this concept another step further. For the parts of the project, or sub-projects or work packages, that are being managed in a traditional waterfall way, why not allow the classic traditional PM, who is managing these sub-projects, attend the Scrum of Scrums meetings to ensure coordination between these parts of the project and the other parts being handled with Scrum? To make sure all this works smoothly, the traditional PM will need to understand very well how Scrum works and why parts of the project are being handled with Scrum. The Scrum Master representatives to this Scrum of Scrums meeting will need to understand why parts of the project are being managed in the traditional way and be tolerant and open-minded to that approach as well. Now, the graphic in Figure 1.13 looks like the one in Figure 1.14. Does this Scrum of Scrums approach provide a ready solution for handling almost all large, complex projects where there are many stakeholders and stakeholder groups? Also, could we keep expanding on this idea so that for even larger and more complex programs, we can go to a Scrum of Scrums concept? No, I think there are limits to how far we should attempt to take this idea. We must still deal with the number one risk that we defined earlier. Define scope so the approved requirements are smart, but also where boundaries and exclusions are defined, and the stakeholders are all on the same page. This is the hard part of project management. In Agile, we are transferring the primary responsibility for accomplishing this from the classic fully accountable PM to the product owner. But doing such a transfer doesn't readily solve the problem or simplify the difficulty of accomplishing this task. In a large, complex project or program with many stakeholder groups, we may need multiple product owners representing key functional business areas, and these product owners may have different needs and goals. There can be incompatibilities at this level, and even different political goals in the organization. So, this could still be very difficult. When there are incompatibilities on the priorities of features, stories, and requirements, someone is going to have to be empowered to make the final decision. If almost all of the sub-projects are being handled with an Agile methodology, then we are delivering incremental tangible value very quickly, in 1 to 4 week iterations, so that will make it much easier to see the value and, therefore, the priority of what is being created. But someone has to be either a fully accountable PM or a fully accountable product owner and make a decision on priorities and formally accept what is being created in the project. It's essential that the right product owner be chosen. You do not want to have a situation where 4 or 5 iterations have passed and the sponsor for the project vetoes what the product owners have approved, and we have to go back to square one. One danger of trying to employ a Scrum of Scrums concept or multiple project teams, whether the teams are using an Agile approach or a traditional approach, is letting the number of Scrum teams or number of sub-projects get out of hand. On the FBI Sentinel project, Sutherland said it was essential to reduce the number of stakeholders on the project, and a key part of their success when they adopted a Scrum approach was to reduce the staff from 220 to 40. Also, on the Medco project we previously mentioned, stakeholders were deadlocked on what should be included in the project and what the priorities of the requirements should be. When they adopted a Scrum approach for handling their impossible constraint, they dramatically reduced the number of requirements and were able to get agreement on the priorities. On a hybrid project, it's still going to be essential to maintain focus on the 20% of the requirements that will meet 80% of the need. With multiple product owners representing different business groups and with potentially 10 to 20 sub-projects, this is going to be more difficult to accomplish than when we're managing one Agile project. Nevertheless, it's key that this be done. Lastly, if we use a Scrum of Scrums approach, or we have multiple sub-projects, there needs to be independence between the sub-projects and the Scrum teams. The teams need to be as self-directing as possible. If there are many dependencies between the sub-projects and the sub-projects are highly coupled, then a predictive planning approach is going to be needed. In the 1970s, when I started my career doing systems design and programming, hot topics were modular programming, go-to-less programming, and top-down design. An excellent book on this subject is Reliable Software Through Composite Design by Glenford Myers. A key point Myers made was that to successfully create reliable software, the program modules needed to be modularized in a top-down, hierarchical way, and the modules needed to be as loosely coupled or independent as possible. This is very reminiscent of one of the key qualities of a well-written story, that it be independent of other stories and features. This is part of the INVEST acronym for well-written stories. Stories should be independent, negotiable, valuable, estimable, small, and testable. I said earlier that we must keep the parts of the project where we are using Agile totally independent and distinct from the parts where we are using a traditional or predictive planning approach, and I would like to make some qualifications. Though this is generally correct, there can be benefits in using some aspects of Agile on a traditional/predictive project, especially using Agile communication techniques, such as a burn-down chart or Kanban board. Also, using Agile brainstorming techniques, facilitation techniques, and prioritization techniques can add a lot of value. In Chapter 3, we will explore in much more detail how Agile can add on key capabilities in processes defined in the PMBOK guide, such as collect requirements and define scope. However, in other key ways, we need to emphasize and caution that it will be a serious mistake to try to require other elements of waterfall and predictive planning while we are doing Agile. For example, in the early planning stages for the Agile portions or sub-projects, it is a mistake to try to put together a very detailed scope statement, a WBS, with all deliverables decomposed down to level 4 or level 5, and a schedule with the critical path defined for the next 6 months out. Doing this is 180 degrees apart from how and why we use Agile. It would also be a mistake to have the classic fully accountable PM run the Agile parts of the project. We need to empower the team, let them choose what they will work on next out of the backlog, and make the team accountable for the project. Chapter 1. Summary and conclusions. I started off this book saying these are very interesting and challenging times for PMs. No pressure, but our companies are really depending upon us to help them survive in these difficult days. Tom Friedman's Age of Accelerations. I also said that project management is a difficult job, and I think that's an understatement. We never have all the resources we need or want for our projects, enough budget, or enough time. Worse, we never have all the power we really need to get agreement on key decisions and to keep the project moving forward as we envisioned. We are not kings or queens, and we cannot force agreement on key decisions or legislate what the outcome will be. This is all about people skills, soft skills, and herding cats. Many of us are managing large, complex projects, and we are working with stakeholders who outrank us not only in our own organization, but also in external organizations. Nonetheless, it's up to us to get everybody onto the same page regarding the vision and requirements for the project and other key constraints. If we don't do this, the project will surely fail, and the blame will fall on us, not on the unreasonable, irrational stakeholders with all their different needs and different wants. If we can pull this off and manage this project to a successful conclusion, this will be amazingly rewarding. There might be more lucrative things to go do, but this will be very rewarding. In today's IT-centric world and technology-centric world, knowledge work projects and software projects are the dominant type of project. Surveys of PMs in the Washington, D.C. PMI chapter, the largest chapter in the world with over 11,000 members, in the past 5 to 10 years, have indicated that more than 70% of our PMs are managing IT projects. And by PMI's own surveys, they reported that more than 90% of all IT projects are being managed using one of the Agile methodologies. Agile is definitely critical for managing most projects today. Nonetheless, I have argued there is definitely a time and place to use the traditional, and even waterfall, project management approaches. There is a lot of sound, core knowledge in the traditional approaches that should not be neglected. We should be big enough and open-minded enough to recognize this. There will be times when we need a fixed price contract with our customer where all the I's are dotted and T's are crossed. In many of these situations, we will need to do predictive planning and use a waterfall approach. However, increasingly, our projects today are knowledge work projects, and we will need to discover and explore requirements as quickly as we can with short iterations. Agile methodologies will be the best choices in these situations. Lastly, many of our projects are large enough and complex enough that parts of the project should be handled with the waterfall approach and parts should be handled with Agile. No one process and no one methodology fits all situations. I am convinced that hybrid approaches will be increasingly important in the coming years. I hope I've made that case for you too, or at least provoked some questions and thought on this topic. Chapter 2. Choosing a development approach for deliverables in your project requires familiarity with the various options, waterfall, iterative, incremental, and agile, and understanding of the